In this video, we are going to be solving 50 possible JAMB 2025 stoichiometry questions in chemistry. Okay, now to solve these problems, you need to be used to the formulas that are being used to solve problems in stoichiometry. But if you are not acquainted with it, I'm going to be making use of these formulas in solving these problems, so you should get used to it. Now, there are 4 questions on the board. You have the first 4, of which the first one says, how many moles of calcium carbonate 4 are there in 2.5 grams of calcium carbonate? What now? 4. You are given the masses, of which the mass of carbon is given as 12, mass of oxygen is given as 16, and the mass of calcium is given as what now? 40. First things first, what is the compound that is being talked about in this case? It is CaCO3. That is calcium carbonate. What now? 4. And we have to find the molecular mass. To find the molecular mass, we are going to solve the masses, sum of the masses of each of these elements. Now, calcium is 40 given in the question, so we have 40 plus carbon is what now? 12. So we have 12 plus oxygen is what now? 16. So we have 16 times the 3 that is given in the formula. Okay, so we have 3 as well. Now, when you sum this up, you are going to get a total mass of 100. Okay, 40 plus 12 plus 16 times 3, that's 48. When you sum all this up, you get what now? A total mass of what now? 100 grams per what now? Mole. Now, they want us to find the number of moles of calcium carbonate 4 that is present in 2.5 grams of that same compound. We are going to make use of the formula for solving number of moles in stoichiometry, and number of moles is given as the mass divided by the molecular mass. Now, number of moles is equal to, what is the mass given in this case? 2.5 grams. So we have 2.5 divided by molecular mass is given as 100. So we have what now? 100. So you have 2.5 divided by 100. That will give you a value of 0.025 moles, of which the correct option to this question is option B. And that is how problems like that are being tackled. Okay, very, very easy. Okay, now for the next question, the question says the number of hydrogen ions in 9.8 grams of tetraoxosulfate 6-acid solution is, remember they said solution, so there is a tendency for us to have what now? Ions present in it. Okay, solution simply means we are going to dissolve this guy in water. Okay, and then take note of the word they use here, ions. Take note. Now let us solve the problem. For us to solve this problem, we need to first know the number of moles of hydrogen ions that is present in 9.8 grams. But how then do we do that? We need to first take note of the number of moles of hydrogen tetraoxosulfate 6-acid in 9.8 grams of that particular compound. Now, H2SO4 is the compound that is being talked about in this case. So we have H2SO4. Okay, now what is the mass of H2SO4? Hydrogen is 1. So we're going to have 1 times the 2 here. So we have 2 plus sulfur is 32 plus oxygen is 16. Okay, times 4. Now when you do the math, you are going to get a total mass of 98 grams per mole for this compound. What is now the number of moles? Number of moles is equal to mass over molar mass. Remember, the mass was given as 9.8. So we have 9.8 divided by the molar mass is what we just calculated, which is what now? 98. Hence, number of moles is equal to 9.8 divided by 98. That is going to give us 0.1 moles. Okay, so we have 0.1 moles of H2SO4 instead of 9.8 what now? Grams of that guy. Now, the next thing we want to do is get the number of moles of ions, of hydrogen ions that is present in 0.1 mole. Okay, now when you dissolve H2SO4 in water, okay, H2SO4, when you dissolve the water to form a solution, you are going to get 2 moles of the hydrogen ion, okay, and then we have the radical, which is SO4 minus. This equation is telling us that 1 mole of H2SO4, because simply 1 mole will dissolve the water, 1 mole of H2SO4, okay, 1 mole of this compound is going to give us 2 moles of hydrogen ions. Hence, 0.1 mole of this compound, 0.1 mole of this compound is going to give us what? Let us call it X. So when you cross multiply, you are going to get X is equal to 0.1 times 2. That will give you 0.2 moles of hydrogen ion. But the question doesn't want us to find the number of moles of hydrogen ion present in this compound. That's not what we're asked to find. We're asked to find the number of what now? Hydrogen ions. Okay, we already know now that there are 0.2 moles of hydrogen ion present in this compound. But what they want us to find is the number of hydrogen ions. Now you should take note that 1 okay, 1 mole of hydrogen ion. Before we can get 1 mole of hydrogen ion, or before it will exist, we need to have a number that is 6.02 times 10 to the power 23 ions of that hydrogen what now ion before we can call it what now 1 mole. We need to have this number. Example, before we can have 1 mole of a marker, we need to have this number of marker before we can call it what now 1 mole. So which means 1 mole of a hydrogen ion simply means we are having 6.02 times 10 to the power 23 what now ions of what now the hydrogen ion, okay, or 6.02 times 10 to the power 23 what now hydrogen ions. Okay, now take note that this number is fixed. It is called the Avogadro's what now number. So we are having 1 mole to give us this, which means 0.2 mole of hydrogen ions is going to give us how many hydrogen ions? That is 0.2 is going to give us, let us call it y. So our final answer now becomes y is equal to 0.2 multiplying the value we are having here. Okay, if you use 0.2 to multiply the value we are having here, you can do it manually. Okay, this is 2 times 10 to the power minus 1. Okay, so this becomes what now 22. That is 10 to the power 22 times 2 times 6.02. That will give you 12.04. From here you can now rearrange it as 1.204. okay, bringing this one is going to give us an additional 10. okay, 1.204 times 10 to the power 23 what now ions of the hydrogen. Okay, so which of these options gives us the answer? 1.204 approximately 1.20 times 10 to the power 23. That is option D. Okay, so that is how problems like this are being solved. If you're having issues with it, you can as well make use of a calculator if you're having issues with calculating. But it's best you know how to calculate these things, as it is an easy math, okay, to solve with. Now the next question on the board says, what mass of SO2 contains the same number of molecules as 0.8 grams of what now? Methane. Okay, notice that they say what mass of SO2, which is silicon fluoride, okay, contains the same number of moles or molecules rather as 0.8 grams of what now? CH4. What they are trying to say is that the number of moles of silicon fluoride should equal the number of moles of methane. That is what they are trying to say. Okay, so remember the formula for number of moles, mass over molar mass. Okay, now what mass of SO2? That's what they are saying. Okay, so we don't know the mass of L now. SO2 rather. Okay, so we have SO2 divided by the molecular mass. What is the molecular mass of sulfur fluoride? Okay, sulfur fluoride they already gave us as this should be SO2. They already gave us as 64, so we have 64 is equal to, okay, what is the mass of methane given? That is 0.8 divided by the molecular mass given is 16. So we have 16. From here we can break it down. 4 here is 4 and 4 here is 0.2. Okay, now 2 here is 2, 2 here is 0.1, 2 here is 1, 2 here is 32. So M is equal to 32 times 0.1, that is 3.2 grams, which means 3.2 grams of silicon fluoride. We have the same mass as 0.8 grams. We have the same number of moles rather as 0.8 grams of what now? Methane. Option what now? Option A. Okay, now the last question on the list for the first 4 on the board says 1 mole of a compound MHCO3 has a mass of 84 grams. Now this 1 mole that is being said in this question should spark up something in your mind. Okay, what should it spark up? It should spark up the fact that the question talking about 1 mole simply means that 1 mole of this compound is equal to the molecular mass, because we are talking about just what now? 1 mole. The definition of molecular mass simply means what now? The mass of 1 mole of that compound or substance. Okay, that is what molecular mass means, which means that 1 mole of this guy is simply equal to what now? The molecular mass. That is, by summing up the masses of the individual elements here, we should get the what now? The molecular mass. Hence, we don't know the mass of H, of M rather, so we have in M plus the mass of H, which is hydrogen, is given as 1. So we have 1 plus carbon is given as what now? 12. Plus oxygen is already what now? 16 times the 3 that is given in the formula. We have what now? Times 3. And this is equal to what now? 84. Okay, why we are equating into the mass is because what now? They said 1 mole. Assuming they said 2 mole, it means we would have been multiplying 84 by 2. If they give us 10 moles, we would have been multiplying 84 by what now? 10. So that is how it is being done. From here we are going to have M plus 12 plus 16 times 3, that will give you what now? 48 is equal to 84. From here we can do the math. M is equal to 84 minus 12, minus 48. Okay, when you do the math, this should give you 23. Okay, so this should give you 23 what now? Grams. Okay, this should give you 23 grams, which means the mass of N in this formula, according to the question that is given to us, is what now? 23. So which of these options best describes the answer that we just got? It is what now? Option D. Okay, now these are the first 4 out of the 50 possible JAMB2025 questions. We still have about 46 more examples to go, so stay tuned while we solve the next 46 questions. Here are the next set of questions on the board, and number 5 says, how many molecules of phosphorus P4 are present in 496 grams of the substance? Okay, we are also giving the mass of phosphorus atom as what now? 31. Now you notice that in this case they're talking about P4. P4 simply means we're having 4 atoms of phosphorus, of each weighing what now? 31 units. Okay, so what will be the total mass of the P4 atom, or the molecular mass of what now? The P4. That will be equal to 4, since we're having 4 of the atoms, times the mass of what now? 1 of it, which is what now? 31. That is going to give us the total molar mass of 124 grams per mole. Okay, 124 grams per mole. 4 times 31 is going to give us what now? 124. Now we are asked to find the number of molecules. For us to find the number of molecules, we must first know the number of moles that are present in this what now? In this mass. You are giving the mass as what now? 496 grams, and we want to find the number of moles. Remember, number of moles is equal to mass divided by molar mass. Okay, and then the mass is given as 496 grams divided by molar mass, which is 124 grams per mole. Okay, that's going to give us an answer of 4 moles. Okay, 496 divided by 124 is going to give us an answer of what now? 4 moles. Now that we know that we have 4 moles of P4 present in 496 grams of the substance, how then do we solve for the number of molecules? Okay, you have to keep in mind that 1 mole of P4 will always contain 6.02 times 10 to the power of 23 what now? Molecules. Okay, that is Avogadro's number. This value you are seeing here is what now? Avogadro's number. In some books or in some questions, it will be given as 6.0, of which in this case it's actually given as 6.0. Okay, so it's best we use what is given in the question. Okay, this one is an approximate value of the one I just wrote here. Okay, so 6.0 times 10 to the power of what now? 23 molecules is what we're going to have in 1 mole of what now? P4. Okay, which means when we're having 4 moles, of P4, what then are we going to have? Let's call it X. Next thing we're going to do is cross multiply. 1 times X is X. 4 times 6.0 times 10 to the power of 20. What would that give you? Now 6 times 4 is going to give us 24. So we have 24 times 10 to the power of what now? 20. Writing this in standard form, we're going to get X is equal to 2.4 times 10 to the power of what now? 24 molecules. Okay, that's what we're going to get. Okay, so which means we're having 2.4 times 10 to the power of 24 molecules inside of 496 grams of what now? This substance, which is what now? P4. Which of the options best describes the answer? That is option D. Okay, 2.40 times 10 to the power what now? 24 molecules. Now the next question on our list is, what is the mass of 2.3 moles of sodium? What is the mass of 2.3 moles of sodium? Now I have in sodium, we don't know the number of moles. Okay, but we are being asked what is the mass. Okay, we are given the number of moles as 2.3, and we are being asked what is the mass. First things first, you need to take note of the formula for calculating mass, or the relationship between mass and number of moles. It is written up here, and it says number of moles is equal to mass divided by what now? Molecular mass. Okay, we are giving the number of moles as what now? 2.3, but we are not giving the molecular mass. Now there are some element that it's useful or very helpful to take note of the molecular masses. Okay, elements like sodium and chlorine are the most common. Hydrogen, oxygen, these are the most common elements. So in this case, we are not giving the what now? The molecular mass of sodium. Now the molecular mass of a sodium molecule is actually 23 grams per mole, which means we have 23 grams inside of 1 mole of what now? The sodium. Okay, so which means molecular mass was given, or molecular mass should be noted as what now? 23 grams per mole. That's what it means. Okay, so having the number of moles in mind as 23, it means we are going to have 2.3, which is number of moles, is equal to mass divided by what now? 23. Okay, mass divided by 23. Hence, m is equal to 2.3 times 23. Now, when you do the math, what would that give you? 2.3 times 23. That's going to give us a value of 52.9. 52.9. Now, 52.9 is the mass. 52.9 grams. Okay, 52.9 grams. But it's not in the option. But 52.9 grams is actually approximately 53. Okay, this is approximately 53 what now? Grams, which is option A. Okay, this one is one of the easiest questions to come across in stoichiometry, just to find mass or molar mass. Okay, so these are formulas you should take note of. Number of moles is equal to mass divided by what now? Molar mass. Very, very useful. Okay, so you should take note of that. Now, looking at question 7, okay, it might be quite tricky because it looks long, but trust me, it is easy. Okay, looking at question 7, the question says, upon heating 125 grams of a solid, that is, we are having a solid that is weighing 1.25 grams, okay, and then we apply heat to it. Now remember, when you apply heat to some certain substance at a particular temperature, they tend to undergo chemical changes or reactions, okay, and it is a solid. Now they notice that 280 cm cube of a gas measured at STP. STP simply means standard temperature and what now? Pressure. Okay, now they measured 280 cm cube of a gas at STP, okay, which were evolved as a residue of 0.7 grams was left. Now residue simply means what is remaining. Let me explain. We're having a solid like this, and then we'll apply heat to it. Now we'll now notice that some gases left the solid, okay, after heating. Some gases left the solid. After these gases left the solid, where it was now remaining a mass of 0.7 grams. That was what was left. Okay, the initial mass was 125 grams. This is the mass. After heating, a gas left the solid, and what was left was 0.7. Now, if you ask, what will be the mass of the gas that left? It will simply be the initial mass before the gas evolved minus the final mass. Okay, so that is something you should take note of. Okay, so first of all, the mass of the gas that what now evolved will be what? 1.25 minus 0.7. Okay, that should simply be the what now? The mass. Let's first of all solve for that. So I'm going to have 1.25 minus 0.7. That is going to give us an answer of 0.55. 0.55 grams to be the what now? The mass of the gas that what now leaves. Okay, let me write it. The mass of what now? Gas. So the mass of gas that what now evolve is what now? 0.55. Now I asked what? Calculate the molar mass of the gas. We have to calculate the molar mass of the gas, and they also give us the volume. So we have two things. We have the mass of the gas at 0.55 grams, and then we have the volume. Okay, so we have the volume of the gas as well as what? 280 cm cube. Now take note, in chemistry, we'll most likely be dealing with dm cubes. Okay, so to convert from cm cube to dm cubes, before we start solving, we have to divide this by 1000. Dividing 280 by 1000, we're going to get the value of 0.280 dm cube. So now I have the volume, I have the what now? The mass of the gas. Now, before we proceed to solving for the molar mass, remember, molar mass is simply the mass of 1 mole of a substance. When you weigh 1 mole of a substance, it gives you what now? The molar mass. And 1 mole of a substance will always contain this number of what now? Molecules. That's what it means. Before we get 1 mole, we must have this number of molecules. Okay, it must be what now? 1 mole. And then again, in terms of volume, it must occupy a volume of what we call 22.4 dm cube, also given in the question. Molar volume of a gas at STP, okay, 22.4 dm cube. So at STP, okay, the mass of a substance that is having this volume is what now called the molar mass. Okay, so at STP, the mass of a substance having this volume 22.4 dm cube, any substance at all, whether it's a gas or any element at all, okay, that is in gaseous form, when it has this volume, okay, the mass is usually the what now? The molar mass. So what we are trying to say is that they also give us the mass at the volume at STP that was measured 280. So what we are trying to say is that if 280 cm cube, or rather we've converted it, so I'm going to make use of 0.28. So if 0.28 dm cube, okay, was the volume that was obtained when the mass was given as 0.55, okay, when the mass was 0.55 grams, what will be the mass when the volume is what now? 22.4. Okay, so 22.4 dm cube. We are going to get what now? A mass of what now? Unknown. Let's call it what now? X. Next thing we'll do is what now? Cross multiply as usual. So x times 0.28 will give you 0.28x equals 0.55 times 22.4. Okay, so what will be the value of x? It is easy. We have to multiply the right hand side and then divide by 0.28. Okay, so 0.55 times 22.4 divided by 0.28. That's going to give us a value of 44 what now? Grams per mole. The only reason why we are permitted to write grams per mole, okay, I should have written grams and then come here, explain, and then write why it is what now? Grams per mole. Okay, the only reason why it is what now? Grams per mole is because it is what now? At STP containing what now? This volume. Any gas that contains this volume at STP simply means now the weight of that gas or the mass of that gas is equal to its molar mass, because it's simply what now? 1 mole. 1 mole of a substance is same as what now? The molecular mass having the same weight. Okay, so which of the options? Option B is the correct answer. 44 what now? Grams, or 44 grams per mole. Okay, that's what it simply means. The next question on the board says, how many moles of iron 3 oxide are contained in 1 kilogram of the compound? Now, the trick to solving this problem is actually you being able to write out the formula for iron 3 oxide. Now, the formula for iron 3 oxide is actually Fe2O3. That is the formula for iron 3 oxide. It's formed by combining Fe3 plus and O2 minus. Okay, that is what forms the iron 3 oxide. Okay, now for the iron 3 oxide, we are first going to calculate the molecular mass. Okay, so the molecular mass of iron 3 oxide is equal to, what is the mass of Fe? 56. So we have 56 times the 2 that is given here. We have 2 plus oxygen is given as 16 times the 3 that is given here times 3. So what will be the molecular mass? When we do that to our calculator, we are going to have 56 times 2 plus 16 times 3. That's going to give us a value of 160 grams per moles. Okay, 160 grams per moles. That's the molecular mass. Having the molecular mass in mind, we have to find how many moles. Remember, number of moles remains the same. It's equal to what now? Mass divided by what now? Molar mass. So what is the mass given in the question? 1 kilogram. Now 1 kilogram has to be converted to grams. Take note. The units that are used in chemistry calculations are usually grams when you're talking about mass. So if you're giving kilogram or any unit, convert it to grams. Also for volume, we make use of dm cube. So when you're giving cm cube, ensure to convert to what now? Dm cube. That's the decimeter cube. Okay, so the mass is given as 1 kilogram. That's 1000 grams, because kilo represents 10 to the power 3. So that will be 1000 divided by 160. Okay, so the number of moles will then be equal to 1000 divided by 160. That gives us a value of 6.25 moles. Now, which of the options should be the answer? We have option what now? D, 6.25 moles. So you see, calculations in chemistry is easy. All you have to do is practice multiple problems. Now, we've succeeded in solving 8 questions so far, and here are the next set of questions. Okay, so here are the next set of questions on the board. Number 9 says, the number of atoms of chlorine present in 7.45 grams of KCl is, now the element that is being talked about is what now? KCl. So we want us to find the number of atoms. So we must first take note of the number of moles of chlorine that is present in this compound when it is having 7.45 grams. Okay, but first let's solve for the number of moles of KCl. Now we are given the mass of KCl in this case as 7.45 grams. What will be the molecular what now? Mass. What will be the molecular mass? To solve for the molecular mass, it will be what now? The molecular mass of K plus what now? That of Cl. We are not given the mass. Remember I said there are some elements that you should have in mind. Okay, so for potassium, the molar mass is what now? 19. Plus for chlorine it is what now? 35.5. Now when you do the maths, 35.5 plus 39, what do you get? 39 plus 35.5. You get a total mass of 74.5. Okay, 74.5 grams per mole. Okay, for KCl. Now what will be the number of moles? Number of moles remains mass over molecular mass, and the mass is given as 7.45 divided by 74.5. Okay, now to divide this, you can just move this twice. That will give you times 10 to the power of minus, or you can move it once to this point. Okay, if you don't know what I'm doing, you can simply watch our videos on indices or work with your calculator. Okay, so you can move in one, that gives us 4.5 to the power minus 1. So these guys both cancel out. That means the number of moles is what now? 0.1 mole. Okay, like I always say, if you don't understand what I did there in the calculation, use your calculator, or it's in knowledge of indices. You can watch our videos on indices to understand how to do these calculations. Okay, so that is the number of mole. We have 0.1 mole of KCl inside of this guy. Okay, now what is the number of moles of chlorine inside of 0.1 mole of this compound? Okay, now we just discovered that, or rather we know that 1 mole of KCl contains, notice that there are no numbers attached to Cl in this compound, which means contains 1 mole as well. Assuming there was a 2 in front of this Cl, you have what now? 2 moles. 1 mole of what now? Chlorine, which means 0.1 mole of KCl is going to contain what? Let's call it X. Because multiplying, you are going to get X times 1 is X, 0.1 times this one is what now? 0.1. Okay, so obviously, the number of moles of chlorine present in 0.1 mole of KCl is what now? 0.1 mole as well. Okay, now let's now go to the redo to find the number of atoms. Now we know that 1 mole of a chlorine molecule, okay, 1 mole of a chlorine molecule is going to contain how many atoms? It contains the Avogadro's number, which is usually 6.02 times 10 to the power of 23 what now? Atoms. In this case, I'll give you 6.02, so you must make use of 6.02. Take note. When I give you 6.0, make use of 6.0. Use what is given in the question. Okay, how do I know we are giving 6.0? Because if you look at the options, we're having 6.0, 6.0 as part of the option. So it's a common sense. Okay, so that is for 1 mole. And then what if we're having 0.1 mole of what now? The chlorine molecule. So when we are having 0.1 mole of the chlorine molecule, we are going to get what now? Let's call it Y. Because multiply Y times 1 is Y. Okay, 6.02 times 10 to the power 23. This 23 times 0.1, what are we going to get? 6.02 times 10 to the power of 0.1 times this, I'll give you what now? 22 atoms. Okay, so these are the number of atoms. 6.02 times 10 to the power 22 atoms. That is option B. That is how problems like this are being solved. Okay, now for question 10, how many atoms of oxygen are present in 8.8 grams of carbon 4 oxide? How many atoms of oxygen are present in 8.8 grams of carbon what now? 4 oxide. Okay, so how many grams of oxygen? Now we are going to do that. Let's do the maths. How many grams of oxygen? Now, the mass of CO2, which is carbon 4 oxide, we are giving carbon 4 oxide. So the mass of CO2, okay, is what now? 8.8 grams. And I have to find how many what now? Atoms of oxygen are in this guy. We're not asked to find how many atoms do we have in this mass of CO2. Okay, we're not asked to find the number of atoms. We're asked to find that of what now? Oxygen. Okay, so now we first need to calculate the number of moles of CO2 that is present in this mass. Okay, it is easy. Let's say the first one for the molar mass. So the molar mass of CO2, carbon is what now? 12. Oxygen is 16. Since we're having 2 molecules of oxygen, multiply by 2, that will give you 32 plus 12. That will give you what now? 44 grams per mole. Okay, 44 grams per mole. So what is the number of moles? Number of moles is equal to mass divided by what now? Molecular mass. Okay, number of moles equals mass divided by molecular mass. So mass is what now? 44. Okay, 88.8 rather. 8.8 given in the question divided by molecular mass is what now? 44. So the number of moles here will be equal to, we can move the decimal point one, that will give you so that will be 0.1. That will be 0.2 rather. 0.2 mole. Okay, so you have 0.2 mole, okay, inside of 44 grams of CO2. Okay, now we're asked to find the number of atoms of oxygen present. Before we do that, we need to know the number of moles that is of oxygen that is present in 0.2. Okay, so we can see that, or we know that in 1 mole of CO2, we're having 2 molecules of oxygen here. So it means in 1 mole of CO2, 1 mole of CO2, just a CO2 molecule, we're having 2 moles of oxygen atom here. So we're having 2 moles of oxygen. Okay, so what if we're having 0.2 moles of CO2? So when we're having 0.2 moles, we're going to get, let's call it X. We don't know. Multiplying X times 1 is X. 0.2 times 2, that will give you 0.4 mole of oxygen. Okay, now in 0.4 mole of oxygen, what then are we going to have? Now we'll now come to the statement, which is 1 mole of oxygen atom, okay, or oxygen molecule. 1 mole of oxygen molecule, okay, contains 6.02 times 10 to the power of 23 what now atoms. Okay, now here is something you should understand. 1 mole of a substance contains 6.02 times 10 to the power of 23 what now atoms. 1 mole of a substance contains what now 6.02 times 10 to the power what now 23 atoms. I've said it while solving the previous problem, so something you should take note of. This number is called the Avogadro's number. Okay, hence when we're having 0.4 mole of O2, what then are we going to get? Let's call it what now? Y. Multiply. Y times 1 is what now? Y. So 0.4 times 6.02 times 10 to the power of 20. So what are we going to get? So 0.4 times 6.02 times 10 to the power of 23. What are we going to get? We're going to get 2.408 times 10 raised to power what now? 23 what? Atoms. 23 atoms. So the correct answer is option. Now approximately this is 2.41. Okay, so the correct option is option C. 2.41 times 10 to the power what now? 23 what now? Atoms. That is for option C. Okay, very easy approach to it. Now the next question on the box is, what is the mass of potassium hydroxide? First of all, what is potassium hydroxide? Potassium hydroxide is KOH. Please take note that this is an alkali. Okay, if you've learned of inorganic chemistry, you should be used to some of these compounds. Okay, NaOH, KOH are common alkalides. Okay, or common bases. Now, what is the mass of potassium hydroxide? Okay, potassium hydroxide present in 50 cm cube of 2 mole per dm cube solution. Now, I think this is the first time I'm coming across the problem since we'll be solving these 50 possible questions in the 2025 UTME. Okay, this is the first time I'm coming across a statement like this. Okay, measured in mole per dm cube. Now, moles per dm cube is what we call concentration. Concentration simply means the amount of substance we're having in a solute or in a solution. Now, I'll talk about what we call molarity. That is MOLARITY. Okay, molarity. It talks about the concentration, which is what now? Moles per dm cube. Number of moles of solutes present in what now? In a solution. Okay, or in 1 dm cube of a solution. We also have what we call molarity. MOLALITY. Okay, now molarity talks about the number of grams that is present in a dm cube of a solute, okay, or in a solvent rather. Then we have what we call normality. That one has to do with number of equivalent what now units present in a solution and solute and all. Okay, we talk about all of that when we deal with the topic that has to do with what now? Titration and so on and so forth. Okay, now this question says, what is the mass of potassium hydroxide present in 50 cm cube? So the volume we're having in this case is what now? 50 cm cube. Remember, we have to convert to dm cube. We have to convert from centimeter cube to decimeter cube. That is by dividing by 1000. So dividing by 1000, you get 50 divided by 1000. That will give 0.0 what now? 5 dm cube. So we've converted it. Okay. Up next, we are given the concentration. Let's call it C. Concentration is what now? 2 moles per dm cube. Okay. 2 moles per dm cube. Now I ask to find the mass. Before we can find the mass, we need to know the number of moles that is present in here. We're already giving the volume. Okay. Now take note of the formula. Number of moles is equal to concentration times what now? Volume. And take note, your volume should always be in dm cube. Your volume should always be in dm what now? Cube. Okay. So the number of moles in this case is equal to what is C? C is 2 times volume is 0.05. Okay. So number of moles is equal to 2 times 0.05. That should give you 0.1 moles. Okay, you should be good with calculations. You should be good with calculation because the JAMB exam doesn't require you make use of calculators. Okay, so N is equal to what now? 0.1 what? Mole. Now that we know that N is 0.1 mole, we are going to write it out. N is equal to 0.1 mole of KOH. Now, what about the molar mass? Okay, what about the molar mass? Molar mass of KOH. Okay, potassium has a molar mass of what now? 39. Oxygen has a molar mass of what now? 16. And then hydrogen is what now? 1. Okay, so 39 plus 16 plus 1, that is going to give you 40 plus 16, that will give you 56. Okay, 56 grams per mole. Let's now solve for the we're asked to solve for the mass. Okay, remember, number of mole is equal to mass divided by molar mass. So mass is equal to number of moles times molar mass. Now when you do the math, mass will be equal to number of moles is 0.1 times molar mass is 56. So mass is equal to 5.6 what now? Grams. Which of the options should that be? 5.6 grams. Now we take a look at the option. You notice that there is no 5.6. I think it should be 5.6 if not an error from my end. So I think it should be what now? 5.6 grams. But let's be sure that there is no mistake to make sure it is what now? Correct. Okay. First things first. Converting volume to dm cube divided by 1000, you get 0.05, which is correct. Okay. Now 0.05 times 2. 0.05 times 2 gives 0.1. So this is correct as well. Okay. And then molar mass 56, which is 39 plus 16 plus 1, we have 36 times 0.1, so that'll give 5.6, which means the correct answer is what now? 5.6 gram, which is option what now? B. Now number 12 question says the ratio of number of molecules of 4 grams of hydrogen to that in 32 grams of oxygen is. Now notice that the question is talking about molecules in this case. When we talk about molecule, we are making use of H2 and O2. If you are trying to solve a question like this and make use of O, it means you are wrong, because O is what now? Just an atom. Why O2 is what now? A molecule. Okay, molecule of hydrogen as well is what now? H2, not what now? H, which means the mass in this case will be what now? 16 times 2, which is what 1 times 2, which is what now? 2, and this one will be 16 times 2, which is what now? 32. These are the masses. So if you make use of 16 and you make use of 1 here, you probably get a wrong answer. Okay, now also we don't have to solve for the number of molecules before we get the ratio. We can just solve for the number of moles and then get the what now? The ratio, because number of moles is directly proportional to number of molecules. Also, do not make the mistake of making use of the masses. You just say, okay, since they want us to find ratio, just do 4 ratio 32. That would be wrong, which will be giving around 4 ratio 8. Okay, if I'm not mistaken, that will be giving around 4 ratio 8. Okay, that will be wrong as well. Okay, so you have to find what now? Either the number of molecules and do the ratio, or the number of moles. It is number of moles that is directly ratio to directly related to the number of molecules. That is, as the number of moles increase, okay, the number of molecules what now? Increase. Or as the number of molecules increase, rather, the number of moles should what now? Increase. So what will be the number of moles? Remember, number of moles is equal to mass divided by what now? Molecular mass. So for H2, what will be the number of moles? What is the mass given in the question we're having for? Molecular mass that we calculated is what now? 2. Then for O2, mass given in the question is what now? 32. Molecular mass we calculated is also what now? 32. Now 2 here is 1, 2 here is 2, 32 here is 1, 32 here is 1. So we're going to be left with what now? 2 ratio what now? 1. Why? There is 2 here and there is what now? 1 here. So I left what now? 2 ratio 1. So the ratio of hydrogen to what now? Oxygen is what now? 2 ratio 1. That is option what now? A. Very, very easy question. Now look at number 13. Number 13 says, which of the following is the same as 24 grams of magnesium? And we're giving different masses. Now looking at the option, which of them is same as 24 grams of magnesium? Now all of them are carrying molecules, which means they want us to find which of these guys we have the same number of moles as what now? 24 grams of what now? Magnesium. So the first thing we want to do is find the number of moles of magnesium, then compare it to the option. Number of moles remains mass over molar mass. So what will be the number of moles first of all? Okay, number of moles of magnesium, number of moles is equal to mass divided by molar mass. So number of moles is equal to, what is the mass in this case? The mass is given as 24. So you have 24 divided by, what is the molar mass of magnesium? 24. Okay, 24, which means we're having just 1 mole of magnesium. Okay, we're having just 1 mole of magnesium. So which of these one will also give us 1 mole? Okay, now we're going to start with the first one. We are going to start with the first one. The first one gives us, now, a molecule of hydrogen weighs what now? 2 grams. So we're going to have 1 divided by 2. That will give you 0.5. And we're getting 1. Okay? Now, check the next one. 16 grams of oxygen molecule. An oxygen molecule actually weighs 32. Not 16. Because they said what a molecule. So if you make a mistake of using 16 to solve, you get 1. Taking that as the answer and you mark it. But it's very wrong. So that will be 16 divided by 32, giving us 0.5, not correct. And we have 32 grams of oxygen molecule. Oxygen molecule weighs what now? 32 grams. So 32 divided by 32, that will give us what now? 1. That should be the correct answer. But let's check number 5 to show that it is what now? Or option D to show that it's what now? Also wrong. Okay, 35.5 divided by what now? chlorine molecule. Okay, now for chlorine molecule, it weighs what now? Normally chlorine weighs 35.5. Okay, that's what it weighs, 35.5. Now the molecule is what now? Cl. Okay, when you divide 35.5 by Cl, 35.5 divided by a molecule of chlorine atom weighs 35.5 times 2 rather. So you have 35.5 times what now? 2. That's 71. So 35.5 divided by 71 will not give you 1. So the correct answer is what now? Option C. Okay, option C, 32 grams of molecules. Here are the next questions on the board, and question 14 says the chloride of a metal M consists of 79.78% of chlorine by mass. Okay, what is the empirical formula of the chloride? Now we are given the masses of the element. When looking at the molar mass of element M, it should tell us that it's aluminum, because aluminum has a molar mass of 27. Okay, but still we are going to solve like we do not know. Okay, what is the empirical formula of the chloride? Now the chloride is the compound that is being formed. Okay, now for M, we are having a percentage of, now we're not giving the percentage, but we're giving the percentage of chlorine by mass, which is 79.78. But the total percentage of the masses in a compound, okay, is usually what now? 100%. So that of chlorine is 79.78, which means that of mass M or element M is 100% minus 79.78%. That is going to give us, okay, when you do the maths, 100 minus 79.78 is going to give us 20.22. So we have 20.22%. Okay, now to solve for the empirical formula, we are first going to divide by the masses. Okay, so this is element M and this is what now? Cl. So we are going to have 20.22 and then we'll have 79.78. Divide each of them by their masses. Okay, that is by their molecular masses. Okay, so for M, the molecular mass is 27, and for Cl, molecular mass is 35.5. Okay, so that is 20.22 divided by 27. That gives us 0.749. Let's put it in 3 decimal places. Okay, 0.749. And then for 79.78 divided by 35.5, we are going to get a mass, or a value rather, of 2.247. Okay, now the next one we're going to do is divide each of these by the value that is smaller. Okay, in this case 0.749 is smaller, so we're going to divide both sides by 0.749. 0.749, 0.749. This is how you calculate for empirical formula. There are other examples here, so it should be easy. Now this one cancels this one, so we are left with 1. Okay, we show what the value we just got, that is 2.247 divided by 0.749 is going to give us the value of 3. Okay, we are getting a value of 3. This means that the ratio of M to Cl in the compound is what now? 1:3. And we can just come directly, I'll write it as M and then the number there, which is 1, then the next compound Cl and the number there, which is what now? 3. But whenever you're having 1 in front, it doesn't mean anything. We don't have to write it. We just write the compound directly, okay, without putting 1 in front. So I'm going to have MCl3, and that is option C. Okay, that is how you solve for the empirical formula. Now the next question on the board, question 15, says an oxide of nitrogen contains 69.6% of oxygen, okay, by mass. Its empirical formula is, okay, so we're having nitrogen and oxygen in this case. So we're going to come here and write nitrogen and oxygen, the same process in which we used in solving for the empirical formula. Now the percentage which was given was oxygen 69.6, so we have 69.6, and then for nitrogen, how do we get it? We simply have to subtract this from 100. Okay, so that's 100 minus 69.6. 100 minus 69. 100 minus 69.6. That's going to give us 30.4. 30.4. Next, what we're going to do is divide through by their molar masses. Now, for oxygen, the molar mass is 16, and for nitrogen, the molar mass is 14. So you have 30.4 divided by 14. That will give you 2.17 in 2 decimal places. 2.17. Okay, and for oxygen, we have 69.6 divided by 16. That gives us 4.35. 4.35. Next, we are going to do is divide by its smaller one, remember. So 2.17. 2.17. This one cancels this one, so I left with 1. Ratio 4.35 divided by 2.17. That's going to give us a value of 2. Okay, so which means the compound that is being formed is N, because N, we wrote N first, so we have N. What is the number in front? 1. So we have oxygen. What is the number in front? 2. Remember, we don't usually leave 1 in our answer, so we have to remove it. Anyone that is 1, we have to what now? Neglect it. So we have NO2. Okay, and that is option D. Okay, so that is option D. So the other that is being formed is what now? NO2. Now the next question on the board says, question 16. Upon heating 1 dm cube of a monatomic gas, which is Y, okay, it combines with 1.5 dm cube of oxygen to form an oxide. The empirical formula is, now in this case, they're not giving us percentage by mass, they're giving us volume. Okay, but you have to remember what we call Avogadro's law. Okay, Avogadro's law says that when elements are combining, they do that in simple volumes or ratio. Okay, that is the volumes and number of moles are directly related. Okay, that is the more the number of volumes that is reacting, the more the number of moles. So we can simply make use of the concept of Avogadro's number to solve for this. Okay, now we are having an element Y combining with what now? Oxygen O, and 1 dm cube of the element. They also say is what now? Monoatomic. That is the atomicity of element Y is what now? 1. So we are having 1 dm cube combining with 1.5 dm cube. Now having dm cube can also be changed into mole because of the law I just stated. Okay, Avogadro's law of combining what now? Volume. Okay, so I can choose to ignore these dm cubes and assume it to be what now? Moles. Okay, now writing this in a fraction, I have 1 ratio 1 over 5 is 3 over 2. So if I cross multiply, this becomes 2 ratio what now? 3. Okay, 1 ratio 1.5. We don't use decimals in ratio, so you have to convert it. So this is same thing as what now? 2 ratio 3. But then again, the question said, does the element is monatomic? That is, it has an atomicity of 1. Okay, and then oxygen, we know oxygen is diatomic. Now what we are going to do from here, we are going to multiply by their atomicity. So I'll write it here. Multiply by the atomicity of the element. Okay, now the atomicity of what now? Y is what now? 1. So 1 times 2 is what now? 2. Ratio atomicity of oxygen is what now? 2. 2 times what now? 3 is what now? 6. So we're having 2 ratio 6. Now we can break this down. 2 here is what now? 1. Ratio 2 here is what now? 3. So this is what now? The simple ratio that we're going to get, which means the elements YO will now be Y. What is the number in front? 1. O, what is the number in front? 3. Remember, you should not leave your answer in terms of a compound that has 1 in front. So our answer now becomes YO3, and that is option what now? D. Very, very easy. This is how we solve for problems involving empirical formulas. Okay, and then again, we are now having question 17, which is 5 grams of an oxide of a metal M gave 4.00 grams of the metal when reduced with hydrogen. Okay, we actually reduce with hydrogen. Okay, sometimes. Now you understand this when you watch our videos on oxidation and reduction. Okay, where we get to that. Okay, now the question wants us to find the empirical formula of the oxide. Okay, so we're having an oxide of metal M. Okay, and O's. We don't know what the oxide is, so we're having M and O. Okay, now what we need is the mass. We don't need percentage because we're not giving percentage. Percentage is directly related by mass. Okay, so there's no need to start solving for percentage. Okay, so for the mass, 5 grams of an oxide of a metal M. Okay, now the oxide contains M and oxygen. Take note, this 5 grams is not the mass of M. Okay, rather is the total mass. So if it gave 4 grams of the metal, it means we are having the mass of the metal to be 4. So what will not be the mass of oxygen? It will be 5 minus what now? 4. So that is what now? 1. Next thing, divide by the molar masses. So oxygen is 16 divided by 16, and the element is having what now? Molar mass of 64. Okay, I think that should be copper, but let's just assume we do not know. So that is 4 divided by 64, which will give us 0.0625, and then 1 divided by 16 is also 0.0625. Okay, we're having the same number, so there's no smaller number, just divide through. Okay, so divide by 0.6, 0.0625, 0.0625. This one here is 1, this one here is also 1, so we're having 1:1, which means our element is M1O1, which is same thing as MO. Okay, that is the compound that is being formed. That is option what now? B. Now that is how we solve problems on empirical formulas. Let's take the next set of questions. Next question on our list is question 18. Now the question says, what is the empirical formula of an organic compound containing 40% carbon and 6.67% hydrogen per mass? Okay, in just the same way we'll be solving the other ones for empirical formula. So we are having C, H, and O. This is general form: carbon, hydrogen, oxygen. So for the carbon atom, it's containing 40% of carbon, so we have 40, and then for hydrogen we have 6.67. Then how do we get the percentage of oxygen? Simply to subtract both of them from 100. So that will be 100 minus 40 minus 6.67. That's going to give us 53.33%. Next, dividing by the molar mass is 16, 1, and then 12. Okay, so 53 divided by 16, we are going to get a value of 3.33 approximately. Now divided this one, you get 6.67, and then divided 40 by 12 rather, we are going to get 40 divided by 12, we are going to get 3.33. Okay, now 3.33 is the smallest one here, so we can divide through by 3.33, divide through by 3.33, divide through by 3.33. Now this one here will give you 1, this one here will give you 1, and this one here will give you what now? 2, which means the formula C1H2O1, which is same thing as CH2O. Okay, and that is option C. Now it's easy to solve this question because you can simply eliminate option A and B. They are not having oxygen. Okay, so those ones are already out. So you are left with what now? 2 and C and D. Okay, so it is quite easy. Now looking at the next question, the question says an element A has the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p3. Now the combination of A with halogen X can give compounds of which of these formula? Now how do we know the possible formulas that can be formed in terms of this electronic configuration? First of all, getting the total number of electrons is what we're going to do. Okay, so you have 2 plus 4, that's 6, plus 6, that's 10, plus 2, that's 12, plus 3, that's 15, which means the total number of electrons is what now? 15. Now what is the electronic configuration of this same element in terms of the theory of 4 digits form? Okay, that is, it will be 2 8, okay, and then 2 8, 2 plus 8, that's 10. Okay, we're moving for 15, so we have what now? 5 left. Okay, now we know that these elements tend to obtain a duplet or octet configuration. Now for this guy to obtain an octet configuration, it needs to take in 4 electrons. Okay, so if it takes in 4 electrons to make this 8, it becomes what now? Stable. Okay, so it will either take in 4 electrons. So if the element which was given as A takes in 4 electrons, it will be represented as what now? A minus 3 before it takes takes part in the chemical reaction. Okay, but if it gives us this 5, it will be what now? A plus 5, right? So if it reacts with halogen X, okay, there will be what now? A 3 attached to the halogen or a 5 attached to the halogen. So looking at the options, obviously option A. Now this one has 5 only and this one has 3 only. So you notice that if you thought of this or you thought of this, they would have been wrong, because these two compounds can actually be what now? Be formed in terms of what now? The halide that is being created. Now looking at the next one, question 20. The question reads, the molar ratio of hydrogen to carbon in an organic liquid compound is 2:1. I'm first going to write that down. Okay, the molar ratio of hydrogen to carbon is 2:1. What now? 1. On evaporation at STP, 0.24 grams of the compound produced 64 cm cube. Remember, we have to convert this to dm cube as well. Of vapor. What is the molecular formula of the liquid? Now, this ratio we are given is actually telling us the empirical formula, which means the empirical formula will be C. There is one here, you don't have to write it, H, and then hydrogen is what now 2. That's what it means. Do not make the mistake of writing since they gave it 2H1 and C comes first, you write C2H1, you get it wrong. Okay, so it's actually what now CH2. Okay, now this is the empirical formula. With this empirical formula, we can eliminate one of these options. We know that obviously option C will be out, because if we reduce the ratio, we get CH, which is not the empirical formula. But if you check for all these ones, when you reduce each of the options, you get what now CH2. Okay, so you have to solve to get one of those options. Now to do that, we are asked to find molecular formula, in this case not empirical formula. And to get molecular formula, you need to get molecular mass. How do you solve for molecular mass? In our previous example, I talked about when we are having a volume, okay, of 22.4 dm cube at STP, the mass of that gas at that point is actually the molar mass of the compound. Okay, but first of all, let's convert the volume to what now? Dm cube. Okay, so 64 cm cube, we have to convert to dm cube. That is by divided by 1000. That is going to give us 0.064 dm cube. Okay, let's now solve for the molar mass. Okay, so if this mass is produced, which is 0.24 grams, is produced, okay, at STP, and the volume is 0.064 dm cube. Okay, if this mass occupies volume of this one, okay, it means which is at STP, the mass that is going to occupy a volume of 22.4 dm cube will be the what now? The molar mass. Okay, from here you can cross multiply. So X is equal to 22.4 times 0.24 divided by 0.064. Okay, so when you do the math, you are going to get 22.4 times 0.24 times divided by 0.064. Okay, so we get the value of 84. That is the what now? Molar mass, 84 grams. Okay, now that we know the molar mass, to solve for the molecular formula, we are going to bring it this empirical formula, which is CH2, okay, times N equals the molar mass. Okay, so we want to solve for the value of N. Now the mass of carbon in this case is what now? 12. So we have 12 plus mass of hydrogen is what now? 1 times the 2 there. Okay, times N equals 84. So 1 times 2 is what now? 2 plus 12, that's what now? 14. Okay, so to get N, we are going to have 14N is equal to 84. Okay, so how do you solve for value of N? That is 84 divided by 14. 84 divided by 14. That gives us 6. So N is equal to 6. Now, to get the molecular formula, we're going to use this N to multiply what is inside of this bracket. So N, which is 6. So 6 times C, which is what now? C6. N times 2 is what now? H12. Okay, that is the correct answer, which is option D. C6H12 is the correct answer to the question. Okay, that is how you solve for molecular formula for questions like this. It is very easy. All you have to do is practice more exercise. Trust me, if you are able to practice through all these 50 questions that we are solving on the board, you are likely going to come across 1 or 2 of these questions in your examinations. Okay, and it will be easier and faster when you are solving, because you've already what now tackled these problems. Now for 21, the question says, which of the following formulas is correct for compounds of an element y having a combining power of 3? Now, when an element is having a combining power of 3, simply means the valency is what now? 3. And when it combines, this is how elements combine. Let's say we're having an element valency of 3, and let's say oxygen 2. When it combines, they exchange what now? Radicals. So this becomes Y2O3. Okay, so if it combines with oxygen, we're going to get this. Okay, of which we can already see that this option what now? B correct. But let me show you why it is not the other options. For example, sulfur. Okay, for example, it combines with sulfur. We have Y3. Sulfur is having a valency of 2. When it combines, this should be Y2S3. And this one is not Y2S3. Rather, we're having YS3. So that's why this one is wrong. And then for chlorine, the same thing. For SO4, SO4 is having a radical of what now? 3. Okay, minus 2 rather. Okay, and this one is having a radical of 3. So we should be having Y2 SO4 in brackets what now? 3. That is why all of these are wrong except option B. That is how problems like this are being solved. Let's take the next questions from 21 down to question 22. All right, the next set of questions on the board, number 22 says, what is the percentage by mass of carbon in the compound Na2CO3 10H2O? Okay, now you can see that this compound is actually hydrated, containing a decahydrate, that is 10 molecules of water, and we are asked to find the percentage by mass of carbon. To find the percentage by mass of carbon, it will be the mass of carbon that is inside of this place divided by the total mass of the compound, okay, times 100%. So to find the percentage of carbon by mass, it is equal to, what is the mass of carbon in this case? That's 12, divided by the total mass. Sodium is 23 times 2, that is 46, plus carbon in this case is what now? 12, plus oxygen is what now? 16. 16 times 3 is 48, so we have 48, plus water is what now? Having a molar mass of 18 times 10, that is 180, okay, so times 100%. Now we do the math using a calculator. We are going to get 12 divided by 46 plus 12 plus 48 plus 180, okay, times 100. That will give you 4.19, which is approximately 4.2%. 4.2% approximately. That is option D. So that is how we solve for percentage by mass. Always take the mass of the compound or the elements you have to find divided by the total mass of the compound times 100. So you're assuming there was a 2 in front of carbon. I would not have written 12. I would have written 12 times 2, okay, which is total mass. Okay, now the next question on our list is, what is the percentage by mass of aluminium in this compound? The same way, percentage by mass of aluminium is equal to the mass of aluminium is what now? 27. And there is a 2 here, so you have to multiply by 2. Remember what I just said. Divided by the total mass, that is 27 plus, times 2, that is 54. Plus, in brackets, we're having sulfur is 32. Plus oxygen is what now? 16. Now 16 times 4 will give you 64. Times the 3 that is outside, times 100. Okay? Now when you do the math, you are going to have 54 divided by 54 plus, in brackets, or 3 in brackets, we have 32 plus 64. Okay, that gives us a value of 15.78. Okay, 15.78. Get 15.78%, which is approximately equal to 15.8%, and that is option A. Okay, very, very easy to understand. And then for question 24, it says, what is the value of X in the molecular formula Pb, you have seen the formula here, if the percentage by mass of nitrogen is 8.46. Now, since you are giving the percentage by mass of nitrogen, it means it's what you are going to use to solve for X. Okay, now I just said that percentage by mass, in this case of nitrogen, okay, which was given as 8.46, will be equal to, what is the mass of nitrogen in this compound? Nitrogen is 14, and there's X there, so that would be what now? 14X divided by, what is the mass of lead? That is 207, okay, plus nitrogen is 14, oxygen is what now? 16. 16 times 16, that's 48. So you have what now? 14 plus 48. I'm going to write it 14 plus 48. Okay, in brackets, what now? X, right? Times 100. Okay, so let us do the math. From here, we're going to have 8.46 is equal to 14x times 100. That is 1400x 1400x divided by 14 plus 48. That is going to give you 14 plus 48. That's going to give you 62. So you have 207 plus 62x. Remember there is an x here. So from here, what we have to do is solve for x. Okay, let us cross multiply. Now we have 207 plus 62x. So we have 207 plus 62x. From here, the calculation in chemistry has ended. All you have to do is do for maths. Okay, all you have to do is solve for x. So it's quite easy. Okay, and that will be equal to, I brought this one here. So we have 1400 divided by 8.46. I'm trying to use the shortest possible cuts available. 8.46. That's 165.48. So you have 165.48 x, right? So for collect like terms, you are going to have 165.48x minus 62x is equal to 207. So this answer we just obtained minus 62. You are going to get 103. So you get 103.48x equals 207. Now 207 divided by this answer, are going to get 2. So x is equal to 2 approximately. That is the value of what now? X. So according to the question, the value of x we just solved for is what now? 2. Okay. Now practice makes perfect. You have to solve these questions or rewind the video to get a better understanding of this part. Okay. Now over to questions on oxidation. The first question says, what is the oxidation number of nitrogen in HNO2? Okay. What's the oxidation number of nitrogen in HNO2? Now, to solve for the oxidation number, we are having HNO2. Okay, let's call the oxidation number of nitrogen X. Remember, this is a compound that is not having a charge, so the net oxidation number is equal to 0. What is the oxidation number of hydrogen? That's +1. Okay, plus the one of nitrogen is unknown, that's X. Oxidation number of oxygen is -2, so we have -2 times the 2 that is here. Okay, and it's equal to 0. Okay, so from here we have 1 plus X. 2 times -2, that's -4, equals 0. Okay, so taking everything, the numbers to this side, we have x is equal to 4 minus 1, so x is equal to 3. Hence, the oxidation number of nitrogen in this case is what now? +3, and that is option A. Very, very easy. Okay, now in most compounds, oxygen has an oxidation number of -2, and hydrogen is what now? +1. Okay, sulfur is usually around 4. Now, there's the next question on the board. The oxidation number of sulfur is equal to -2 in which of these? Okay, in which of these compounds does sulfur has an oxidation number of -2? We are going to solve for it. Now, for SO2, what would be the oxidation number? Okay, let's say we don't know for sulfur. Let's call it S. Oxygen is what now? -2 times 2, and this is equal to 0. So S minus 4 is equal to 0. So S is equal to 4. So the oxidation number here is what now? 4. Okay, so they said the oxidation number of sulfur is equal to -2 in which of these? So this one is out. Now let's check for SO2 minus, SO4 minus, rather SO4 2 minus. Now anytime you're having a charge, you equate the oxidation number to that charge. That means that compound or the radical is having an oxidation number of the number on top. Okay, these ones do not have, that's why we use 0. Okay, so for sulfur we don't know, that's S, then plus oxygen is -2 times 4, and this is equal to -2, right? So S 2 times -4, that's -8 equals -2. So S is equal to 8 minus 2, that's what now? 6. Oxidation number of this one is 6 out. We are looking for the one that will give us what now? -2. Now for this one, S8. Oxidation number of elements that are standing alone, not reacting, and they are not having charges on top, it is always 0. So the oxidation number of this one is what now? 0. And then for HS2, hydrogen is what now? +1 times what now? 2 plus S is equal to 0. So we have 2 plus S equal to 0. So S is equal to what now? -2. Hence, the oxidation number of H2S, that is hydrogen sulfide, is what now? -2. And that is how a problem like that is being tackled. Now look at the next one. The oxidation number of oxygen is different from its value in water. In which of these? First things first, you need to know the oxidation number of oxygen in water, which is what now? -2. Okay, water is H2O. Okay, what's the oxidation number? Hydrogen is +1, so we have +1 times 2 plus, let's call it X, and it's equal to 0. So 2 times 1 is 2 plus X equals 0. So X is equal to -2. That is how we know that the oxidation number of oxygen is what now? -2 in water. So now what they want us to find is the oxidation number of oxygen is different from its value in water. In which of these? So they're trying to say among these 4 options, 3 are having an oxidation number of -2 for oxygen, except one. I want to look for that one. So let's check. Now, what is the oxidation number of oxygen here? Sulfur is +4. Okay, so we have +4. Let's solve and check. So we have +4. Oxygen is unknown. Let's call it X. So we have +2X is equal to 0. So 2X is equal to -4. X is what now? -2. So this one is good to go. Okay, it is good to go. And it's having an oxidation number of -2 just like water. So we're going to we cannot pick this one as the answer simply because it's having the same. We need the one that is not having the same, because that is what the question requires us to do. Now for H2O2, that's called hydrogen peroxide. Let's check. Okay, for hydrogen peroxide, what will be the oxidation number of oxygen in that case? Okay, now for hydrogen it remains what now? +1. So we have +1 times 2 plus oxygen is unknown. So we have what now? 2x equal to 0. So this is 2 plus 2x equals what now? 0. So from here 2x is equal to -2. Okay, hence x is equal to what now? -1. You notice that this one is different. Okay, instead of -2 like water, it is now having what now? -1. So this first of all could be our answer, but let's check the others to make sure we are on the right track. So we are having the hydrozonium ion, which is H3O plus. Okay, so what will be the oxidation number? Hydrogen remains what now? +1. +1 times 3, that is 3. Plus oxygen is unknown, let's call it x, equals what now? +1. So from here, x is equal to +1 minus 3. X is equal to -2. Notice that it is what now? The same as water. Oxidation number of oxygen here is what now? -2. -2. And for this one, let's see if it is what now? -2 as well. So for the ozonium ion, or the hydrogen ion rather, we're going to have oxygen is unknown, x plus hydrogen is 1, and it's equal to the radical we're having here, which is what now? -1. So x is equal to -1 minus 1. X is what now? -2. Since we obtained -2 for these ones, okay, and these ones, it means this one is the only exception, okay, having a different oxidation number, which is hydrogen peroxide. Okay, take note. The oxidation number of oxygen in hydrogen peroxide is usually what now? -1, which you just calculated. Now, 28th question says an element E forms the following compounds. It's bromine, and these are the following compounds. The observation illustrates that law of conservation of mass, law of definite proportion, law of multiple proportion, and law of chemical proportion. Now, looking at these options, before you be able to answer this question, you need to know the definitions of these three, basically the first three. Okay, now law of conservation of mass simply talks about the fact that matter cannot be created nor destroyed. Okay, that is what it talks about. Or total mass on the reactant side of a chemical reaction should always equal that on the product side. Okay, so option A cannot be part of it. This is what now irrelevant to this question. Now the battle should actually be between 2 and 3. For number 2, we're having law of definite proportion. Now what is law of definite proportion? Law of definite proportion simply talks about the fact that when two elements react to form a compound, they usually do this in the same proportion. Okay, no matter when or how they combine. That is what we're trying to say is, if for example we are having copper and oxygen combined to form a compound, copper and oxygen combines to form a compound, even if you prepare this in the laboratory or in the industry or anywhere at all, okay, provided it is a pure sample that is being provided, when you solve for the percentage by mass, which we have been doing, when you solve for the percentage by mass, you always get the same value no matter where we get CuO from. Okay, no matter where we get copper oxide from, okay, or copper 1 oxide from, you must always get what now? The same proportion of copper and oxygen in this compound. Another example, hydrogen, H2O, or rather water, H2O. Okay, no matter where we get the water from, as far as it is what now? Pure, whether rainwater, tap water, we must get the same proportion of hydrogen. That is the ratio of proportion of hydrogen to oxygen. That compound has to be what now? Fixed. Okay, provided the sample is what now? Pure. Now that is what law of definite proportion is talking about, and we don't need it. Now law of multiple proportion. Law of multiple proportion states that when two elements combine to form different compounds or a variety of compounds, just as you are seeing in this case, E and BRO, they combine and they are forming different compounds. This one is EBRO2, EBRO3, EBRO4. Okay, a variety of compounds, 3 different compounds. So when two elements combine to form a variety of compounds, okay, what the law is trying to say is that the element inside of it that combines with a fixed mass, in this case, which one is having a fixed mass? E, because E is not having any number attached to it here. This one is not having any number attached to it. This one is not having any number attached to it, which means the masses inside of this place, then what they are what now? Fixed. Okay, they are what now? All fixed. Okay, now if they are all fixed, it means the other element, which in this case is bromine, that is the element combining with the fixed one. The fixed one we have identified it to be E. So the one that is combining with the fixed one, which in this case is what now? Bromine. They are usually in simple ratios. Now check, the number of moles in 1 mole of EbRO2 is what now? 2. So for this first compound, we are having the number of moles of what now? 2. For this second one, 3. For this third one, 4. They are usually in what now? Simple ratios. Okay, they are usually in what? Simple ratios. So we have 2 ratio, 3 ratio, for which are what now? Simple ratios. Hence, we say that it is in accordance with the what? Law of multiple proportion, which is option C. Okay, now that is how problems like this are being tackled in calculations and under laws of multiple proportions and the likes. Now there will be more examples provided on this one as well, and still we are going to proceed. This is number 28 and the next one is number 29. Okay, now the next question on our list says, in which of the following is gallium showing an oxidation number of +3? We're having NaGeO and we're having the other compounds in the option. Now it is simple and straightforward question They simply want us to show or find which of these compounds have gallium to have an oxidation number of +3. Okay, so all we have to do is solve from the first down to the fourth option. So for the first one, NaGaO, okay, sodium is having an oxidation number of +1. Gallium, let's call it X, it's unknown. Okay, now oxygen is -2. Now this compound is not having any charge on top or radical, so we equate it to 0. So from here, 1 minus 2 is what now? -1. So we have X minus 1 equals 0. So X is equal to what now? +1. So you notice in this compound, gallium is having an oxidation number of +1. Okay, but they want us to look for the one that has +3. Now let us check. For NaGaOH, okay, sodium is +1, gallium is unknown, let's call it X. Now for oxygen, we're having -2, and for hydrogen, we're having +1, times there's a 4 outside, and this is equal to 0. So we have 1 plus X. Now 1 minus 2 is -1. -1 times 4 is -4. So we have -4 equals 0. From here, X is equal to 4 minus 1. And X is equal to what now? +3 or +3, okay? Which means that the oxidation number of gallium in option B is actually what now? +3. And that is how we figure out the correct answer. Now, when you figure out the correct answer without making mistake, there is no need of you checking C and D. The only dealing is the question 1. But if it's a situation whereby the answer is the option D, you have to keep trying and check the next one to get what now? Option D. Now, the next question on the board is the possible oxidation number of an element with atomic number of 17 are which of these? Now, an element that is having an atomic number of 17, obviously we already know is chlorine. Chlorine is the one having an atomic number of 17, okay? But let's see, let's put in critical thinking and see how we can get the answer, okay? Now, chlorine, or let's say we don't know the element, is just what now having an atomic number of what now? 17, okay? Using the electronic configuration of 2, 8, 8, that is 2 plus 8, which is what now? 10, okay? 10 plus 8, that's 18, but we're having 17, so this should be 2, 8, 7. Now, looking at this element, for it to be stable, it either gives out this 8 or it accepts in a positive what now, or rather accepts in 1 electron. If it accepts in 1 electron, it becomes 8, which is what now? An octet state. It is stable, okay? And when it does that, it means it will now have a net charge of what now? -1, which is its oxidation number when it accepts an extra electron, okay? We're now going to be having what now? 288, right? And because of that extra electron, the number of electrons are more than protons. That is why oxidation number is what now? -1. So it's either -1, or when it gives RD7, or the electronic configuration becomes 2,8. Now, given that 7 means it's going to what now? Have an oxidation state of what now? +7. So it's either +7 or -1, or -1 and +7. Okay. Now, which of these options prove that? Okay, that is option what now? D, -1 and +7. It is that easy. Now, the next one on our list, we're having what is the value of X for the anion? Okay, we're giving an anion here. Now, them telling us that it's an anion simply means that the value of X should be what now? Looking at this one, should be negative, right? Cations are positive, anions are negative. Okay, so since the value of X, they already said what an anion means, X should be what now? Negative. Okay, to tell you that it's an anion. Now, they gave us the oxidation state of Y because the question says if the central element Y has an oxidation number of +2. Okay, so we're going to have +2. Now, cyanides. Cyanides have oxidation numbers of -1. Okay, take note. Cn, they both have oxidation numbers of -1. Just take note. Anyway, you see cyanide, Cn, they have an oxidation number of -1. So no need splitting the carbon from the nitrogen. Okay, so we're going to have plus in brackets -1. There is a 6 outside, so you multiply that 6, and it's equal to the value of X which you are solving for. So I'm going to have what now? X here. Okay, so for me, you have what now? +2 -1 times 6 is what now? -6. Okay, so for which means X is equal to 2 minus 6. That's what now? -4, which is the correct option of D. And that is how a problem like that is being tackled. Now, on the other hand, or the next side of the board, we are having on oxidation and reduction. Now, the question is, consider the following redox equation, and the redox equation is given on the board. Okay, now the oxidation number of manganese, okay, the oxidation number of manganese changed from which of these? Okay, that is, they want us to find out the oxidation number here and then find out the oxidation number here. It is very, very easy. Now the compound or the radical given here is MnO4 minus. Okay, how do we find the oxidation number of manganese? Let's say we don't know the oxidation number of manganese. I'm going to write Mn plus oxidation number of oxygen is minus 2 times the number here, which is what now? 4. Remember, we're going to equate to the number that is on top, which is the radical. Okay, that is what now? Minus 1. So Mn 4 times minus 2, that's minus 8 is equal to minus 1, which means Mn is equal to 8 minus 1, that's what now? Positive 7, which means the oxidation number of manganese on the left hand side is what now? Positive 7. And looking at the option, you can only see we're only having positive 7 as the first one in option B, so we can go ahead and tick it as the answer. But let's be sure. Go to the other hand side, we are going to see Mn2 plus. We cannot no need to solve for it because there's already a charge attached to it, okay? Telling us that this is a cation ion, okay? So Mn2 plus is having an oxidation number of what now? Plus 2. Telling us that the correct answer is what now? From plus 7 to what now? Plus 2, and that is option B. Okay? Going to the next one, we're having a redox reaction over here, and the question says, the changes in oxidation numbers when manganese chloride and hydrogen ions react according to the above equation are respectively which of these? Now they are not being specific, okay, because we're having these four options and we don't really know which of the elements are being talked about, okay? But going through it, I've seen that okay, they're actually talking about manganese, chlorine, and hydrogen. So let's calculate the change in oxidation number. Now for manganese, this radical we're having here, okay, we already calculated it. It's having an oxidation number of plus 7. Look at it, we calculated it above. So you have what now? Plus 7 over here. Now it's changed into what now? Plus 2 here. So what will be the change in oxidation number? Take note, it's always products minus reactants. So it is what now? 2 minus 7, not 7 minus 2. So 2 minus 7 is minus 5. Looking at the options, I can say that, okay, option C has what now? Minus 5 first. Okay, to tell you that that's automatically the answer because minus 5 comes first. Okay, but still, let's go for the others and be certain. Now for chlorine, we're having Cl minus, which means the oxidation state of chlorine here is what now? Minus 1. And that of chlorine here is what now? 0. So 0 minus minus 1. Okay, so remember it's product minus reactant. So 0 minus minus 1. That will give you what now? A plus 1. Okay, that's why I'm having a plus 1 there. And then let's see for hydrogen. Hydrogen is having an oxidation number of what now? Plus 1 over here. How about there? Oxidation number of hydrogen in water is actually what now? Plus 1, right? So you have plus 1 minus plus 1, that's 0, which is 0 we're having here. Okay, that is how questions like this are being solved. We just succeeded in solving 33 questions. A few more to go. Okay, and here we go. All right, so the next question on the board, question 34, says the balance equation representing the reaction between copper and dilute HNO3, that is triazole nitrate 5 acid, is, now you are given an equation in which copper is being reacted with HNO3, and I asked to find the balance equation, that is find A ratio B ratio X ratio Y. So we have to solve for A ratio B ratio X ratio Y. Now if you're writing the JAMB examination and you come across a problem like this, I advise you don't pick the whole equation and go and try to balance it. Rather, use the options. It will be faster. Okay, any examination at all, it will be faster. Okay, except they want you to show your workings. Now, what we are going to do is we are going to make analysis of the options and the equation as well. Now, looking at copper, we are having A moles of copper. If you come to this part, we are having X moles of copper, which means the number of moles of copper here, it should be same as the number of copper here for it to be balanced, right? So A must be same as X, which means A ratio X, that is the first one ratio, the third number, have to be the same value. So if we're having 2 here, this should be 2 as well. If we're having 3 here, this should be 3 as well. Now let's go to the options and see. For this one, we're having 3 ratio 4. Okay, for the first and third number. Since they must be the same, it means this one is out. Now check the other options. 3 ratio 3, fair enough. 1 ratio 1, okay. 4 ratio 4, okay, that's we're having 3 options left, so we've eliminated one. Now let's go to the next one. We're having B moles of hydrogen, and we're having Y moles of hydrogen. Now this hydrogen is carrying 2 attached to it, which means B is equal to 2 times Y, right? Because of 2 that is attached to it, which means we are saying that you have to multiply any number you get for Y before you get B. So if this one is 1, B will be what? 2 times 1, that's 2. If this one is 2, b will be 2 times this, that's 4. If this one is 3, b will be 2 times this, that's what now 6. And this one is 4, b will be 2 times 1, that's what now 8. Okay, now let's go to the options. We've eliminated this one as well. Okay, what I'm trying to say is b is the second one and y is the fourth one. So the second number ratio, the first one must be what now? 2:1. Okay, now check for option b. Notice that if y is 4, b will be 2 times 4, that is 8. This one is good to go. Check for this one. If y is 4, b will be 2 times this one, which means this one is wrong, right? This one is out. Now check for this one as well. If y is this one, b will be 2 times this one is wrong as well. So obviously our correct answer is option b. Now why is that? Simply because you notice that twice the fourth number gives us the what now? The second number, which is just analyzed, and that is how a question like this is being tackled. Okay, on the next question we're having on the board, we're having a redox reaction, and it gives CrO2O72 minus plus 14 hydrogen ions plus n number of electrons. Okay, you can say I underline the n because I have to solve for n in this case. Okay, equals 2 CrO3 plus 7 H2O. I actually underlined this myself to make sure I record that I was solving for n because I did not write anything alongside the question. Or most questions like this, you'll be asked to find the number of electrons. Okay, now to do that, we have to make sure the charges on both sides are balanced. Okay, now for this one, we're having a net charge of -2, which is the one on top. Okay, hydrogen, we're having 14 of this hydrogen ion, so we have plus 14. Okay, for electrons, we have -n electrons, so we have -n, and it's equal to 2 times plus 3, that's plus 6. Okay, there's no charges, so that's 0. Okay, so what will be the next thing? Taking n to the other side and bringing 6 to this side, we get -2 plus 14 minus 6 equals n. Hence n is equal to, now 14 minus 6 is going to give you 8. 8 minus 2, that's 6. So the number of electrons that will be required to balance this whole equation is what now? 6. Very easy. Okay, now question 36 is, which species acts as an oxidizing agent in the following redox reaction? Which species acts as an oxidizing agent? Now it's important for you to know the definitions of oxidizing agents, reducing agents as well. Okay, and how they work, and as well as the oxidation numbers of these guys as well. Now an oxidizing agent tends to oxidize another element and it's reduced in the process. Okay, now since it is reduced in the process, it simply means that for it to act as an oxidizing agent, its oxidation number needs to what now? Decrease, because it is being reduced. So as it's reducing, its oxidation number what now? Decrease or reduce. Okay, so which of these elements does the oxidation number from the left to right actually what now? Decrease. If you check for this one, this is +2 and it increases to what now? +3. So this cannot be an oxidizing agent. Okay, but rather to be a reducing agent. Okay, reducing agents reduce other species and they are oxidized in the process. So since they are oxidized in the process, the oxidation number what now? Increases. So +2 down to +3, this is an oxidizing agent, Fe2+. Now take note, the oxidizing or reducing agent has to be on the left. So if you go through the options and you see Fe3+ and Cl-, Fe3+ and Cl, okay, there's even no Cl-, anyone that you see the product, always remove it, because oxidizing or reducing agent has to be on the left hand side, never will it be on the right hand side. Okay, now Cl on the other hand, which is obviously it because it's the only one left. So you have Cl, the oxidation number is 0 here, the oxidation number is -1 here. Now from 0 to -1, that's a decrease, right? 0 going to -1 is what now? A decrease. So which means Cl2 is the oxidizing agent, and that is option B. Okay, very, very easy. Question 37 says, which of the following species undergoes reduction? Okay, which of the following species undergoes reduction? Now, how do you tell the species which undergoes reduction? Remember, the one that undergoes reduction usually has a decrease in oxidation number, right? And they are also what now? Oxidizing agents, because oxidizing agents is being reduced in the process, and also what now? Decreases in its oxidation number. So I'm going to check through the options, which one has an oxidation number that decreases. For Fe2+, Fe2+ to Fe3+, that one is out. So anything Fe2+ or Fe3+ is out of the option, okay? Because there is an increase. We want a decrease in oxidation number. Okay. Now, for hydrogen, it is +1 here, and for hydrogen, it is what now? +1 here as well, which means it did not change. Okay, it did not change. So this one is out. Okay, so the options that are left with is what now? Option A. But let's still confirm. Okay, they said which of the following species undergoes reduction. Now it's important to also take note that reduction has the different definition. Okay, it is the addition of hydrogen or removal of oxygen. Looking at this option, you've seen that oxygen was there before. On the left hand side, it's no longer there. We removed it. So this guy has been what now? Reduced. Also, you check for the oxidation number of chromium to confirm. Okay, let's check for the oxidation number of chromium. Now, the oxidation number of chromium in this place, let's calculate it. We have 2x, where x is the oxidation number of chromium, times the 2 you're having here, plus, now, oxygen is what now? Minus 2. Minus 2 times 7, that's minus 14. And it's equal to the next charge, which is 0 now. That's minus 2. So from here, 2x is equal to 14 minus 2. That will give you 12. So x is equal to what now? 6. Now notice that the oxidation number of chromium here is 6. And the oxidation number of chromium here is what now? Plus 3. Right? From plus 6 to plus 3, that's a reduction in number. Okay? Which means CrO2O72 minus has been reduced down to Cr. So there are different ways of analyzing, okay, of which I think that's the most safe way of doing it. So the correct answer is option A. Okay, now the next one, question 38 says, how many grams of HCl will be required to react with 5 grams of NaOH, which is what now? Sodium hydroxide. Okay, that's what they are simply asking. First things first, you are going to deal with the reaction. Okay, now reacting NaOH and HCl. Okay, we're having an acid and a base. Okay, when you react these two guys, what do you get? Now sodium is going to combine with chlorine to form sodium chloride. Okay, and OH is going to combine with hydrogen to form H2O. Now you notice that it is even balanced. You don't have to balance it. 1 mole of sodium, 1 mole Cl, so hydrogen on the other side. So it's actually balanced. Okay, now they want us to find how many grams of HCl. So this is what we are looking for. What now? In the reaction. Okay, that's what they want us to do. Now they said when you react 5 grams of NaOH. So according to this reaction, let's see how many grams of HCl will be required. Okay, first of all, we can see that 1 mole of NaOH combines with 1 mole of HCl, right? Now let's convert 5 grams to mole. To convert it to mole, we have to divide by the molar mass of sodium, which is dividing 5 by what now? 23. So it means when we're having rather, we're not going to convert it directly. We're not dividing by 23. That's a mistake. We're dividing by the molar mass of NaOH. Okay, now since we're dividing by the molar mass of NaOH, it means we have to solve for the molar mass of NaOH first. Now sodium is having a molar mass of 23, plus oxygen is 16, plus hydrogen is 1. Now when you add this, you get 17. Now 17 plus this guy is going to give you that should be 40. So the molar mass of NaOH is 40. I did not want to at least start dividing and solving for moles. I think that would be long. Okay, you need experience and solving these things in a quicker way. Okay, now when you check, we are going to need the number of moles because we are dealing with mole and mole. So if we want to deal with this 5 grams, we have to convert this to mole. Okay, so to convert to mole, we have to divide by what now? 40, which is the amount of sodium hydroxide. So you have 5 over 40 is going to produce what now? X. Now this X we are going to get will be in moles because we've converted. Okay, from here X will be equal to the same thing, simply because if 1 mole reacts with 1 mole, it means 5 over 40 will also react to 5 over 40. So when you cross multiply, X times 1 is what now? X. 1 times 5 over 4 is what now? 5 over 4 as well. Okay, moles. So we see that 5 over 4 moles of HCl is all we require. But the question wants us to leave it in grams. Okay, now how do we leave it in grams? We have to calculate the molar mass of HCl. And the molar mass of HCl is equal to hydrogen is 1 plus chlorine is what now? 35.5. Okay, and now we call that number of moles is equal to mass divided by molar mass. Okay, so what will be the mass? The mass will be equal to number of moles times molar mass. Okay, and that is mass is equal to what is the number of moles we just saw for it, that is 5 over 40 times the molar mass, which is 1 plus 35.5, that is 36.5. so the mass will be equal to, let's do that with the calculator. We have 5 divided by 40 times 36.5. That gives us 4.5625 grams. Okay, now which of the options? Option A, approximately. So you have mass is equal to 4.6 grams approximately. Okay, very, very easy. Now the next question on our list, question 39, says the burning of phosphorus in excess oxygen is represented by the equation P4 plus 5O2 . The next question on the board, question 40, says 5.00 grams of a mixture of CaCO3 and CaO liberated 1.32 grams of carbon dioxide on heating. What is the percentage of CaO in the mixture? That is what they want us to find. Okay, now what they are simply trying to say is that there was a mass of CaO, Ca3, that's calcium carbonate, okay, and then another mass of CaO, and they sum up to give 5 grams of a mixture. They did not react, okay, they just sum up to give what now? 5 grams of a mixture, okay. And then on heating, we notice that carbon dioxide was released. Now between these two, if we put them in a container and we heat them, which one is going to give us carbon dioxide? Obviously this one, because it is only this carbon that will break down, right? This one does not even have carbon, so it cannot break down to form it cannot break down, so not even react. Only this part will what now be heated. Okay, so it means that CaCO3, okay, when it is heated, it produces what now? CO2, right? Now, not just CO2, what else is still going to produce? It's going to produce CO2 and CaO, okay? That is carbon dioxide and what now? Quicklime as well. Okay, now let's check to make sure it's balanced. 3 oxygen, 1 carbon, 1 calcium, 3 oxygen, 1 carbon, 1 calcium, which means 1 mole, 1 mole, 1 mole. Okay, now our emphasis should be on carbon carbonate theory and CO2 because that is what is being given in the question. Okay, now first things first, we need to know the mass or the number of moles of CaCO3 in this compound so we can subtract and get the leftover. Okay, the question wants us to find the percentage of CaO in the mixture. What is the percentage of CaO? To get the percentage of CaO, we need to know the mass of CaO in this compound, okay, and then the mass of CaO divided by that mass times 100% to give us the what now? The percentage mixture. Okay, so for this case we're having CaO, CaCO3 rather, of which 1 mole produces 1 mole of CO2. Okay, so how many moles is going to produce 1.32 grams of carbon? We have to convert to moles since we're working with moles. Okay, now 1.32 grams of carbon dioxide. Now CO2 is actually having a mass of what? Let's see. CO2 is 12 plus 16 times 2, that is 32. So this will give you 44. So we have 1.32 divided by what now? 44. Now since 1 mole is reacting 1 mole, it means the mole here will be what now? Also 1.32 over 44. So the number of moles of CaCO3 is 1.32 over 44. Okay, that is the number of what now? The number of moles. 1.32 divided by what now? 44. Now we've obtained the number of moles of CaCO3 in this case, right? Number of moles that produced 1.32 grams of carbon. Now if that is the number of moles that produce 1.32 grams of carbon, okay, what will now be the mass of CaCO3? Okay, so the mass of CaCO3, remember, number of moles is equal to mass divided by molecular mass. Okay, so the number of moles is given as 1.32 over 44, and then it is equal to the mass unknown. What is the mass of CaCO3? That should give you 100. Okay, calcium is 40, carbon is 12, oxygen is 16 times 2, that will give 48, and total of what now? 100. Now when we do the math, the mass will be equal to 100 times 132, 1.32, that's 132 over 44 grams. That is the mass. Okay, now let's put that in decimal. To put that in decimal, 132 divided by 44, that's going to give us 3 grams, right? So you have 3 grams. Now it means the mass of calcium carbonate in this mixture is 3 grams. Okay, so the mass of calcium carbonate in this mixture is what now? 3 grams. If the total is 5, what will be the mass of CaO? What will be the mass of CaO in this mixture? That will be what now? 5 minus 3, which is what now? 2 grams. But the question wants us to find the percentage of calcium carbonate in the mixture. That will be the mass of the percentage of calcium oxide, rather, not calcium carbonate. Percentage of calcium oxide. So how do we find percentage of calcium oxide? It will be the mass of calcium oxide divided by the total mass given, of which you just obtained the mass of calcium oxide to be 2. So percentage of CaO is equal to 2 divided by the total mass times 100. Okay, now 2 over 5 is 0.4 times 100. That should give you what now? 40%, which is option what now? B. Okay, the simple trick to finding the percentage of CaO in the mixture is to divide the mass of CaO, which is 2, by the total mass times 100. And to do that, you have to solve through, okay, to find the mass of CaO. Okay, now the next question on the list says 2 grams of a mixture of Na2CO3 and NaCl were dissolved in a 250 cm cube standard flask. Okay, now in that mixture, 25 cm cube portion of the solution, okay, require 26.6 cm cube of 0.100 mole per dm cube of HCl for neutralization. What is the percentage by mass of Na2CO3 in the mixture? Now this question might look long and scary to some students, but by understanding what is being carried out here, you should be able to solve it. What they want us to find is the percentage by mass of this guy in a mixture of this and this. Now they said 2 grams of these two guys, okay, were dissolved in 250 standard flask, okay, to form a solution. Now after dissolving 250, we're now having a solution of 250. You now took 25 cm cube of the volume of the solution, okay, that is of the solution, and then they reacted it to 26.6 cm cube of 0.1 mole per dm cube HCl, that is HCl containing this volume and this concentration, okay, and they used it to neutralize it. Now since they said neutralize, it simply means that NaCl is not going to take part in the reaction with HCl, but rather it is Na2CO3, sodium carbonate, that is going to react with what now? HCl. So we are simply saying that amongst this 25 cm cube that is being reacted with HCl, only the part that contains Na2CO3 will react with it actually, and NaCl will just remain there without doing anything. Okay, so first of all, let's do the reaction. So we are going to have Na2CO3 plus HCl. What is this going to give us? We are going to get NaCl plus, we are going to be left with H2O and CO2. Okay, take note. Whenever sodium carbonate reacts with HCl, it forms what now? It salts water and what now? Liberates CO2. Now let's balance. Let's see. For sodium, we're having 2 here, and we're having 1 here. Chlorine, we're having, okay. So I think if I put a 2 here and a 2 here, will it be balanced? 2 hydrogen, 2 hydrogen, 2 chlorine, 2 chlorine, 2 sodium, 2 sodium, 3 oxygen, 2 1, and then carbon. Okay, so it's balanced. So it's balanced. Okay, so note now, what is the element of, or the compound of importance here? Na2CO3 and HCl. Okay, that's what we're talking about. So it means we are dealing with what now? These two guys. And we notice that 1 mole of Na2CO3 reacts with 2 moles of HCl, right? Now another thing again, let's now solve. Okay, let's solve for the mass of Na2CO3 that will react. Now we're given the volume and concentration of the HCl 26.6 cm cube. Remember you have to convert to dm cube, okay, by divided by 1000. Okay, so now let's first of all convert these two guys, or let's just solve for the mole directly instead of wasting time. Now we notice that we are given volume and concentration. Now remember that number of moles is equal to concentration times volume. So what will be the number of moles? The number of moles will be equal to, concentration was 0.100, which is 0.1, times volume, which is 26.6 over 1000. Okay, that is the number of mole. Now according to this equation, 1 mole of Na2CO3 reacts with 2 moles of HCl, right? So how many moles of Na2CO3, okay, will react with 0.1 times 26.6 over 1000? Okay, how many moles? So we're going to get x to be equal to, let's solve for x. Okay, now x will be equal to 0.1 times 26.6 divided by 1000, okay, divided by 2. That will give you 1.33 times 10 to the power of minus 3 moles. Okay, so we are going to get 1.33 times 10 to the power of minus 3 moles of HCl that will react. Okay, 1.33 times 10 to the power of what now? Minus 3 moles of HCl is what we are going to get, right? So we are saying that the amount or the number of moles of this guy, okay, that will react to HCl is that guy we should just obtain. Now, they said 25 cm cube of the portion, okay, require 26.6 cm cube of this one, okay, for neutralization. And with the help of this statement, we were able to solve for the number of moles that reacted, which means the number of moles here is what is actually present here. So what we're trying to say is, inside of 25 cm cube, we have what now? 1.33 times 10 to the power minus 3 moles of what? Na2CO3 inside of 25 cm cube. So what if we're now having 250, which is the total one we're now having? 250 cm cube is not going to contain how many moles? So 250 cm cube, notice that I did not cover to dm cube in this case, because cm cube can cancel cm cube, okay? It's going to give us what now? Let's call it y. Now when you first multiply, y will be equal to 250 times this divided by this one, okay? So I'm just going to say the answer we obtain, which is this value 1.33 times 10 to the power minus 3 times 250 divided by 25. That's going to give us a value of y as 0.01 TVT 0.01 TVT what? Moles. Okay, 0.01 TVT what now? Moles. So we're trying to say that we have 0.01 TVT moles of Na2CO3 inside of the mixture. Okay, now they give us in terms of gram. Before we can get the mass of NCl, we have to convert this one to what now? Mass. And for us to convert to mass, we have to multiply by the what now? The molar mass. Now what will be the molar mass? Now sodium is 23, so we have 23 times 2 plus carbon is 12, so we have what now? Plus 12. Oxygen is 16 times 3, that will give 48, so plus 48. That will give what now? 106. So how do we convert this number of moles to what now? Mass. Okay. Now remember that mass is equal to number of moles times molar mass, or number of moles equals to mass over molar mass. So the mass will be equal to, what is the number of moles? This amount 0.01 TVT times what is the molar mass, which is what now? 106 that we just obtained. So multiplying by 106. Okay, we are going to multiply by 106. I will get a value of 1.4098. Okay, so the mass of Na2CO3 is 1.4098 what now? Grams. But what was given in the question is what now? 2 grams. If the mass of this one is that and the total mass is 2, so what will be the mass of NaCl? Simply to subtract that guy from 2. Okay, so the mass of NaCl will be equal to 2 minus 1.4098. Okay, so 2 minus the answer we got, that's going to give us 0.5902. But it doesn't end there. We're not asked to find the mass of NaCl. They asked us to find the percentage by mass of Na2CO3. Okay, so there is no even need to find NaCl. They want us to find percentage by mass of Na2CO3. That will be this mass. Okay, so the percentage by mass will be equal to the mass of Na2CO3 which we obtained, which is 1.4098, divided by the total mass given in the question, which is 2 times 100. Okay, so it's easy. 1.4098 divided by 2 times 100. That's going to give us 70.49%, approximately 70. Okay, so that is what now? Option D. Very, very easy. Okay, if it looks tedious or too much to understand, all you have to do is rewind the video and watch it over again. Also solve more problems or create more problems by changing values after understanding this. Okay, it will help you understand it better. Now over to the next question, question 42. Question 42 says, in the reaction CaC2, okay, that is calcium carbide, react with 2 moles of H2O to give us calcium hydroxide, okay, and ethane. Now this is actually what we do in the preparation of ethane. We want to create ethane. We react with now calcium carbide with cold water. Okay, in this case they are not mentioning if it's cold or not, okay, because they don't want us to produce ethane. They're just telling us that something was produced, or which in this case we know this is what now? Ethane. It belongs to the family of alkynes, okay, the alkyne double bond family. Okay, now that is by the way. Let's solve for what the question is asking for. The question says, what is the mass of solid calcium carbide, that what is the mass of this guy, needed to produce 5.6 dm cube of ethane at STP? Okay, at STP, remember that 1 mole of a substance must contain a volume of 22.4 dm cube. Okay, so if at STP 1 mole, okay, of ethane contains 22.4 dm cube, okay, it means x mole will contain 5.6 dm cube. So x will be equal to x times 22, that's 22.4, okay, x, and so x will be equal to, when you cross multiply, it will be 5.6 divided by 22.4. Okay, so this is the number of mole that we are having of ethane. Okay, that's, or let me rephrase the question. What is the mass of solid calcium carbide needed to produce 5.6 over 22.4 moles of ethane at STP? Okay, moles of ethane at STP. Now, according to the equation, first of all, let's check to make sure the equation is balanced. Okay, now we're having CaC2. Okay, we're having 1 mole of calcium, 1 mole of calcium. Oxygen is what now? 2, so we have 2 here. Carbon is what now? 2, we have 2. Hydrogen is 2 here, 2, that's 4. Okay, so the equation is balanced. Okay, now according to the equation, we're dealing with what now? Calcium carbide and ethane, and you see that 1 mole of calcium carbide produced 1 mole of C2H2, that is 1 mole of ethane, which means X, or let's call it Y moles will produce this number of moles of ethane. Okay, will produce 5.6 over 22.4. Now when you do the mass cross multiply, okay, Y will be equal to simply 5.6 divided by 22.4. Okay, that's the easy trick. So that will be 5.6 divided by 22.4. That's going to give you 0.25 moles. Okay, now the options are in terms of grams because they said what mass. So you have to go on number of moles to what now? To mass. And remember, number of moles is equal to mass divided by what now? Molecular mass. Number of moles 0.25, which you just obtained. What is the mass given in the, okay, we're looking for the mass. Now, what is the molar mass of calcium carbide? Calcium is 40. Carbon is 12 times 2, that will give you 24. So that's 64. Okay, so mass is equal to 64 times 0.25. That'll give what now? 16 grams. Okay, so the mass needed in the question is 16 grams. That is option what now? C. Very, very easy. The next question for the theory, okay, says the volume of 0.2 mole per dm cube of H2SO4 that will exactly neutralize 25 cm cube of 0.0 mole per dm cube NaOH solution is. Now this one is very easy. These questions come from under titration, and we're going to do it here. Okay, now first of all, take note of the formula that the number of moles of acid to the number of moles of a base, okay, is equal to the concentration of acid times concentration times volume of acid divided by concentration of base times volume of what now? Of base. Now to get the number of moles, we have to do the reaction and see. Now H2SO4 is being reacted with what compound? NaOH. Okay, so what will be the reaction? So we have H2SO4 plus NaOH. Now what is this going to produce? So to solving problems like this, you need to first know what is being produced at the end. So H2SO4 plus NaOH reacts to give you Na will combine with what now? SO4. So we are going to get Na2SO4, which is a salt, and then the others are going to form water. So the hydrogen combines with OH, that will give you what now? H2O. Now let's balance. We're having 2 sodium here, so there should be 2 here. But before we put 2, let's make sure. Okay, let's put the 2 and see. Now we put the 2 here, you get 2 moles of Na. So Na is 2 here, Na is 2. SO4 is balanced. Now let's check for hydrogen. We're having 2 hydrogen here, correct? Okay, we have 2 hydrogen here, and on this part we have 3 hydrogen. Okay, we have 3 hydrogen. What else again? Let's check for oxygen. Oxygen is 2 here plus this gives you 6, and oxygen is, this is not 3 hydrogen. That's a mistake. This is SO4. Yeah. So since we're having SO4, we have 4 oxygen. Sorry, 4 oxygen, yes, and 1 oxygen. That's 5. Yeah. And hydrogen is what now? 2 here, not 3. Hydrogen on this part is 2. And on this part, we're having 4 hydrogen, right? Hydrogen is not balanced there. and oxygen is not also balanced. So let's see, what if we want hydrogen to be, okay, what if we put a 2 in front of H2O? So hydrogen there will be 4, and hydrogen here is already 4. Oxygen there will be 4 plus 2, that's 6. Oxygen is 4 here, so we have to, so it's balanced. 2 moles of water, 2 moles of what now? Sodium hydroxide, right? So let's check. Hydrogen here 4, 4. Oxygen here 6, 6. SO4, SO4, and 2. So that's it. Okay, avoid making mistakes and take your time to balance these things. I mistakenly wrote H here, so I was thinking it's what now? H, but I've corrected it to 4. Okay, so avoid making mistakes like that. How do you avoid making these mistakes? Is by solving multiple what now? Exercises. Okay, now that we've done that, we can now see that the number of moles of H2SO4 that we react with NaOH has to be what now? 1:2. Okay, so the number of moles of acid, of this case, the acid is what now? H2SO4. So that's 1. So we have what now? 1/2. So let's go directly to solve. They want us to find the volume of H2SO4. Okay, so what is the number of moles of acid? That is 1, which you just got from this equation or obtained from this equation. Number of moles of base NaOH, that is 2, and is equal to concentration of acid, the volume of 0.2 H2SO4, 0.2 mole per dm cube, that's concentration. So you have 0.2 times volume of acid is what they want us to find. We don't know it, volume of acid, divided by concentration of base was given as 0.05, 0.05 times volume of base is 25. Okay, so from here, the volume of acid will then be equal to, let's do the maths, to then be equal to 0.05 times 25, okay, divided by 2, divided by 0.2. That's going to give us a value of 3.125. So obtain the value of 3.125 cm cube. Approximately what now? 3.12 what now? Option A. That is how problems like this are being tackled. This is question 43. Let's go to question 44 and solve more problems. The next question on the board says, question 44. Consider the equation iron reacting with 2 moles of HCl to give you iron chloride and then hydrogen gas is liberated. Now the question wants us to find the mass of iron that will be required to react with 250 cm cube of 0.1 mole per dm cube HCl. It's very easy. All you have to do is work in moles. Okay. Now first things first, I want to cover this volume and this concentration to moles. Okay. Remember, number of moles is equal to concentration times volume. So number of moles is equal to concentration is 0.1. That is for the acid. Now the volume is 250 cm cube. Remember, you have to work in dm cube, so you are dividing by 1000. Okay. And when you do this math, what you should be getting is now 250 here is 1. 250 into 1000 should give you 4. Okay, so this is 1/40 moles. Okay, that's reacting. So what you have to do is clear this out of your mind and replace it with 1/40 moles. Now they tell you to consider the equation and then they ask what is the mass of iron that will be required to react. Okay, now first of all, let's deal with the mole. According to the equation, first, is it balanced? 1 iron, 1 iron, Cl to 2 Cl. Okay, balanced. Okay, so now according to the equation, we notice that 1 mole of Fe reacts with 2 moles of HCl. Okay, 1 mole of Fe reacts with 2 moles of HCl. Okay, so which means how many moles, let's call it X, of Fe will react to 1/40 moles of HCl. Okay, now we do that, multiply X times 2, that's 2X, is equal to 1/40 times 1, that's 1/40, which means X is what now? 1/80. Okay, 1/80. Now 1/80, let's convert it into decimal. So you have 1 divided by 80. You have 0.0125 moles. The question wants us to find the mass of iron. Okay, what will be the mass of iron? Remember, mass is equal to what now? Molar mass times number of moles. Mass is equal to molar mass times number of moles. Okay, so the mass is equal to iron is 56 times 0.0125 equals, so this value times 56, this was 0.7 grams. Okay, so from the question and the equation given, it means 0.7 grams is going to what now? Be required to react with this amount of HCl. Okay, completely. Now the next question says 2 moles of butane, which is C4H10, okay, reacts with 13 moles of oxygen to give you CO2 and water. Okay, now they've balanced it already. This is an organic chemistry reaction, an exothermic reaction of which butane is undergoing combustion. Okay, so if you studied organic chemistry, you should understand this equation and how to balance it. There's a formula for it. Now let's go straight to the question. From the equation, what volume of oxygen at STP is required to burn 100 cm cube of butane? Okay, now if you look at the options, that in cm cube, so there will be no need to convert. There will be no need to convert 100 cm cube into dm cube. And to solve that is very, very easy. Okay, we are going to make use of the reaction that is being given. Okay, now first things first. We see that 2 moles of butane react with 13 moles of oxygen. Okay, so 2 moles of butane is C4H10, okay, react to 13 moles of oxygen. Okay, now how many moles, since we are looking for the number of moles of oxygen, okay, how many moles of, or rather this number of volume of butane will produce X moles of oxygen. Okay, so let's convert this one to moles. How do we convert 100 cm cube to moles? How do we do that? If 1 mole of butane at STP contains 22.4 dm cube of volume, so let's call it Y moles will contain what? 100. Okay, 100 cm cube. Yeah, but since this one is dm cube, it's advisable to divide by 1000. So you have to divide this one by 1000. Abi? So 0 cancel 0, 0 cancel 0. I left with what now? 0.1, which means y will be equal to 0.1 divided by 22.4. Okay, so y divided by 22 by 4 is the what now? Number of moles of butane that is contained in 100 cm cube of butane at STP. So you have 0.1 divided by 22.4. Okay, so what will be the numbers of moles of oxygen? When you do the math, let's multiply. You get 0.1 divided by 22.4. Okay, times 13 divided by 2. That's going to give us 0.029 moles of oxygen. Okay, so this is the number of moles of oxygen that we've obtained. Now, from this number of moles, we are going to convert it into volume. So, number of moles of oxygen at STP will contain how many volume? Remember, 1 mole of oxygen at STP is going to contain 22.4. Okay, so 0.029 is going to contain, let's call it Z. Now, when you cross multiply, you get Z will be equal to 22.4 times this answer we just obtained. So the answer times 22.4 is going to give us 0.65 dm cube. But the options are cm cube, so you have to multiply by 1000. So multiply this by 1000, you get Z will be equal to, multiplying this by 1000, you get 650 cm cube, which is option B. Okay, very, very easy. That is how problems like this are being tackled. Let's move on to the next one. Okay, on the other hand of the board, okay, we're having the next question, question 46. It says, from the equation, the number of molecules of hydrogen gas produced when 0.5 moles of aluminium reacts completely, okay, with excess HCl. Now, this excess HCl, I'm going to underline it. Excess HCl simply means there is just enough amount of HCl needed to react, okay, and the other ones are left out. Okay, now we're having 2 moles of aluminium. The equation has already been balanced, and they want us to find the number of molecules of hydrogen gas. So we are dealing with what now? Number of molecules of hydrogen gas, and then they gave us 0.5 moles of aluminium. Okay, which means we are dealing with just these two guys. Okay, now from the equation, 2 moles of aluminium reacted to produce 3 moles of a hydrogen gas, right? Okay, so 0.5 moles of aluminium is going to produce what? Let's call it X, because multiplying 2 times X is 2X, 0.5 times 3 is 1.5. So X is equal to 1.5 divided by 2. That's going to give us 0.75 moles. Okay, 75 moles doesn't end there. They want us to find the number of molecules. Now, know that there is 6.0 times 10 to the power 23 molecules in 1 mole of hydrogen, right? So, which means we are going to say if in 1 mole of hydrogen, which is H2, we have 6.0 times 10 to the power 23 what now? Molecules. It means in 0.5 moles, we are going to have what now? Let's call it y. Now, of course, multiply y times 1 is y. Okay, 6.0 times 10 to the power 23, multiplying by 0.75. So 0.75 times 6.0 times 10 to the power of 23 is going to give us 4.5 times 10 to the power of 23. So you have 4.5 times 10 to the power of what now? 23 molecules. Okay, and that is option B. Okay, a very easy question. Now the next question on our list, we are having what volume of oxygen at STP would react with carbon to form 13.2 grams of CO2 in the reaction represented. Now here's the reaction. If you check, you see it's balanced. 2 oxygen, 1 carbon, 1 carbon. Okay, now we are asked to find the volume of oxygen at STP. So we are dealing with what now? This one that will react to produce 13.2 grams of carbon. This one. Okay, first things first, let's convert that grams to what now? Moles. Okay, number of moles is equal to mass divided by what now? Molecular mass. Mass is given as 13.2 divided by molecular mass of CO2. When you calculate this, you get 44. So you divide it by 44. So you have 13.2 divided by 44. That will give you 0.3 moles. So it's same as saying 0.3 moles of CO2. Okay, now from the reaction, we notice that 1 mole of oxygen will react to produce 1 mole of CO2. So 1 mole of oxygen reacts to produce 1 mole of CO2, right? Which means 0.3 moles of oxygen will produce y, because multiplying, you get y to be 0.3 as well. Okay, 0.3 moles of, which means 0.3 moles of CO2 rather. 0.3 moles of CO2 will react to produce what of oxygen? Is there a mistake in this place? Now, 1 mole of oxygen react to produce 1 mole of CO2, which means x mole or y moles of oxygen will produce 0.3. Okay, oxygen should be under oxygen. Okay, do not make that mistake of interchanging it. Okay, so y will still be equal to 0.3, but even at that, make sure not to make the mistake, because when the values are not 1, just like in this case, you will be getting a different wrong answer. Okay, so 0.3 what now? Moles of oxygen, okay, will be required. Now let's convert it into volume. Okay, 0.3 moles of oxygen at STP occupies what volume? Okay, now we know that at STP, okay, 1 mole of oxygen contains a volume of 22.4 dm cube. Okay, so which means 0.3 moles of oxygen will contain what now? Let us call it x, because multiply x times 1 is x. So 0.3 times 22.4 will give you 6.72 dm cube, and that is the correct answer. Option what now? D. That is how problems like this are being tackled. Okay, let's go to the next set of questions, which is this question 47. Let's solve the remaining 50 parts, or the remaining 3 parts of the 50 possible JAMB 2025 chemistry questions. Alright, so the next set of questions are on the board. Question 48 says, how many grams of hydrogen gas will be evolved when 80 grams of magnesium ribom is dissolved in 200 cm cube of 2 mole per dm cube HCl solution? Now the first thing you want to do is the reaction. Okay, magnesium plus HCl, that's going to give you magnesium chloride plus hydrogen gas that is being evolved. Okay, by putting a 2 here, you see that it is balanced. Now you notice that in the other problems we'll be solving, we'll be asked to find something on the left hand side, giving something on the right hand side, or right hand side giving something on the left hand side. But in this case, we are giving something of 2 things on the left hand side, but 1 on the right hand side. Okay, whenever this happens, take note that you'll be required to solve with one of these. And which one are you going to use to solve? We are going to use the one that is the limiting reagent. Okay, this is also an aspect of stoichiometry called limiting and excess reagents. Okay, it means one of them is too much and the other one is what now? Just less. Now it is the one that is less, that is not enough, that will determine what is being produced. Imagine you want to build a house and you need 100 bags of cement and 50 blocks, okay, to build a house, and then you notice that in the end you're now having 1000 blocks, okay, and 50 bags of cement. you notice that the remaining 900 blocks will be useless if there is not enough cement. So the one that is not enough is the one that usually what now determines what will be formed. That is the limiting reagent. Now, how are you going to solve or find the limiting reagent? It is very easy. Looking at this equation, 1:2 is the mole ratio. Okay. Now, how about what was given? Let's see the mole ratio. It means that anytime magnesium wants to react with HCl, it must be 2 times the value. So if there's 1 mole here, this one will be 2. If there's 3 mole here, this one will be 6. If there's 10 mole here, this will be 20. If there's 50, this will be 100. If there's 40, this will be 80. So it's always price of what now? That's of magnesium. Now, what is the mole here? 18 grams of magnesium. When you convert into mole, what do you get? That is mass over molar mass. That is 18 divided by 24. That's going to give us 0.75. Okay, so for magnesium, we have 0.75. Okay, and then for HCl, let's leave out this one first. Okay, let's pause it and leave it out first. Now, if 1 mole of magnesium reacts with 2 moles of this one of HCl, it means 0.75 will react to what? It will be twice this one, right? So that will be 2 times 0.75. That will give you 1.5. Okay, so the ratio of magnesium to HCl in the new reaction will be what now? 0.75 to 1.5. But when you check, let us solve for the number of mole that was given in the question for HCl. So having 200 cm cube of 2 mole per dm cube. Okay, remember number of mole is equal to what now? Concentration times what now? Volume. So number of mole, concentration is what now? 2. Volume is what? 200 divided by 1000. Remember you have to convert to dm cube. 0 cancel 0. So you are left to what now? N as 0.4. Now notice something. In the question, we are given 0.4 moles of HCl. But what we need is 1.5 according to what we just calculated, what we just observed. We see that when we want to solve for this one, we need what now? 1.5. But we are given 0.45 and 0.4, which is what now? Less than 1.5. Okay, so since 0.4 is less than 1.5, it means HCl is the what now? The limiting reagent, and it is the value of HCl that is given in the equation that we are going to use to solve. If you try it in another way, maybe you put 0.4 here, and then which means this one will be half of this one. Okay, that will be what now? 0.2. This one will require half, which means magnesium is in excess and HCl is the limiting reagent. What I'm trying to say is, after solving the 0.4 from the question, I'm going to come and write 0.4. Since it's 1 ratio, so it means this one will be exactly half of this. So this should be what now? 0.2. Now we are giving 0.2. Okay, but in the question, we need 0.2 rather. But in the question, we are giving 0.75, which is way too much. So since we are giving 0.75, it means this is in excess, and it will not determine what will be formed. Just as well, the same way I explained the number of bags of cement and the house. So it's 0.4 that will determine what will be formed. So I'm going to solve with 0.4 and not 0.75. Okay, so we'll come here and we'll say 2 moles of HCl, okay, gives 1 mole of hydrogen. 2 moles of HCl gives 1 mole of hydrogen, 1 mole of the hydrogen molecule. Okay, so 0.4 moles of the HCl is going to give us what? Unknown x. So because multiply 2 times x, that's 2x. 0.4 times 1, that's 0.4. So x is equal to what now? 0.2 moles of hydrogen molecule. Okay, next thing we want to do is convert into grams, because they said grams. Okay, remember mass is equal to number of mole times molar mass. So the mass is equal to number of mole is 0.2. Molar mass was given in the question. Molar mass of hydrogen is 1. So m is equal to 0.4 times 1. That will give what now? 0.4 grams. Okay, rather 2. Molar mass of hydrogen molecule is 2. Okay, because this is H2. Okay, hydrogen gas. It has to be what now? 2. So 0.2 times 2, that will give you 0.4. Okay, you get 0.4, and that is the value, which is option A. Okay, a very easy question. Now the next one on our list is 2 grams of limestone was treated with excess 0.5 mole per dm cube HCl. Okay, now the acid left, since it was in excess, some reacted and some were left. Now the one that was left, okay, at the end of the reaction required 32 cm cube of 0.02 mole per dm cube Na2 CO3 solution, okay, for neutralization. What is the original volume of the acid? This is another very technical and easy question as well. Okay, now first things first, limestone was treated with what now? HCl. That's the first step. So we're going to do the reaction. So limestone, which is CaCO3 plus HCl, okay, plus HCl. When this acid reacts with this carbonate, we're going to get calcium chloride plus H2O plus CO2. Okay, that's what we formed. CaCl, okay, plus H2O plus CO2. Now let's check. Calcium is 1, and oh, for this one, this should be what now? CaCl2, right? CaCl2. Hydrogen is HCl. We're having H2O over there, so when we put a 2 here, we see that it is what now? Balance, right? Oxygen is 3, 1, so it's balanced. This is what now? Calcium chloride, CaCl2, not CaCl. Okay, now after doing this, next thing we want to find first is the number of moles of acid that reacted the first time. Okay, because number of moles can get volume. Okay, so let's get the number of moles of acid first. So the number of moles of acid that reacted with 2 grams of limestone. In this case, how many grams of limestone reacted? Let's not go into mole. Let's just go directly and solve for or which one will be easier? Okay, let's do mole. Okay, 1 mole reacts with 2 moles of HCl. 1 mole of CO2 reacts with what now? HCl, which means 2 grams of limestone, which can be converted into mole, divided by 100. The mass of CO2, which is limestone, is 100. So dividing 2 grams by 100, you get 0.02. So 0.02 moles is going to produce what now? X. When you do the math, X will be equal to 0.04 moles of HCl. So 0.04 moles of HCl is what reacted the first time. How about the remaining parts? Now the remaining part was treated with 32 cm cube of 0.02 mole per dm cube Na2CO3. Okay, we are going to do the reaction over here. HCl reacts with Na2CO3. Okay, so when you do the reaction, you are going to get NaCl plus H2O, and then CO2 will be given up as well. Okay, let's balance the equation. When you put a 2 here and put a 2 here, it will be balanced. So we can see that 2 moles of HCl react with 1 mole of Na2CO3. Okay, now we are given 32 cm cube of this guy. Let's convert it into moles. Okay, so the number of moles of Na2CO3, number of moles of Na2CO3, okay, will be equal to, remember, is what now? Concentration times volume. Okay, what's the concentration? 0.02 times 32. Okay, so we have 0.02 times 32. Now this volume should be in what now? dm cube. So you have to what now? Divide by 1000. Okay, so which means we are going to have 0.02 times 32 divided by 1000. That's going to give us 6.4 times 10 to the power of what now? Minus 4 moles. Okay, now from the equation, 2 moles of HCl reacted with 1 mole of Na2CO3. Okay, now how many moles of HCl, let's call it Y, will react with 6.4 times 10 to the power of minus 4 moles of Na2CO3. Okay, when you do the mass cross multiplying, Y will be equal to this value times 2 is going to give us 1.28 times 10 to the power of now minus 3 what now? Moles. Now here is the trick. We obtained 0.04 moles from the first reaction, and from the second one, 1.2 times 10 to the power minus 3. Part of the acid reacted with this one, part of the acid reacted with this one. That is the one that was main reacted with that. So what will be the total number of moles of acid? It will be this one plus that one. Okay, so this value, we are going to come here and write total number of moles of HCl will be equal to 1.28 times 10 to the power minus 3 plus 0.04. So the answer plus 0.04 is going to give us 0.04128 moles. Okay, now we just obtained the number of moles to be 0.04128 moles. Now we also give you concentration. The concentration with excess 0.5 HCl, okay, 0.5 mole per dm cube HCl. Okay, so that's the concentration. So you have 0.5 mole per dm cube HCl. Now we want to find the volume because that's what the question is requesting. Volume is equal to number of mole divided by concentration, Abi, because number of mole is concentration times volume. Okay, so volume is number of mole divided by concentration. So you have 0.04128 divided by 0.5. When you do the maths divided by 0.5, you are going to get 0.08256. 0.08256. Okay, this is in dm cube, but the options are in cm cube, multiplying by 1000 to convert it to cm cube. This is going to give you 82.56 cm cube. Now this is approximately 80 cm cube. Okay, the closest approximation, which is option D. Okay, and that is the correct answer. Tick. Now, the last question on the board, which is question 50. Okay, we're having zinc being reacted with H2SO4 to give you zinc sulfate plus water. Okay, now the question says, in the reaction represented by the equation above, how much of zinc would be left undissolved if 5 grams of zinc granule is treated with 50 cm cube of 0.5 mole per dm cube H2SO4 solution? Now the trick here is to find the mass of zinc that reacted in this equation, okay, or that reacted with 50 cm cube of this one, okay, and then subtract it from 5 to get the one that is unreacted. First things first, we are giving 50 cm cube and 0.5 mole per dm cube of H2SO4. Let's get the number of mole. Okay, so for H2SO4, remember is what now? Volume times concentration, concentration times volume, and the volume is given as what now? 50. Remember you have to convert to what now? dm cube multiplied by 1000, and then multiply by 0.5. Okay, now when you do the math here, you are going to get 50 times 0.5 divided by 1000. That will give you 1 over 40, which is 0.025. Okay, 0.025 moles. Now if you check the equation is balanced, and according to the equation, 1 mole of zinc, okay, will react with 1 mole of H2SO4. Okay, so X mole of zinc will react with what now? 0.025 moles of H2SO4. Constant multiplying, you get the same value of 0.025 moles. Okay, 0.025 what now? Moles. That's what you're going to get. Now it doesn't end there. They want us to find the amount of zinc that is what now left undissolved. Okay, this is the number of mole of zinc that reacted. Let's get the mass of zinc that reacted. And remember, number of mole is equal to mass divided by molar mass, which means mass is equal to number of mole times what now? Molar mass. And mass is equal to number of mole is 0.025. Okay, times the molar mass of zinc is 65. So you multiply by 65, you get the mass. So multiplying this value by 65, you get a mass of 1.625 what now? Grams. That's what we are going to get. So this is the amount that reacted. How do we now solve for the amount that is unreacted or that was left undissolved? Okay, so the amount that was left undissolved is 5 grams, which was the mass given, minus 1.625 grams. Okay, so 5 minus that answer we're having on the board, that's going to give us 3.375 grams, which is option B. Okay, approximately. Okay, option B. Now that is the correct answer, and that is how problems like this have been solved. Now we succeeded in solving exactly 50 JAMB possible 2025 questions, okay, from stoichiometry. There will be more to come, and we've uploaded more as well. So if you're interested in watching those of our videos that will be helpful in your JAMB examinations, okay, in various courses like maths, physics, and chemistry as well, and other science areas, okay, do well to check our playlist for more videos. Now if you're new to the channel, ensure to click on the notification bell so that when new videos have been uploaded, you get notified about it. I trust you don't want to miss any of these useful videos that will help you pass your exams. And you cannot click on that notification bell without subscribing to the channel. Okay, so ensure to subscribe to the channel. Like this video if you did help find this useful, and then share with your friends. If you have a question, feel free to put it in the comment section, and see you in the next video.